So essentially, immediate mode is an enforced single source of truth.
Some moments, some controls need to work in kind of an exclusive mode. For example, a slider, you start moving the slider and you go completely out of the slider rectangle, and you don't want the mouse to affect other controls while they still being able to move the slider.
Segfault dog. I segfaulted the dog.
Welcome to our UI programming debate. We're gonna talk about various stuff with a special attention to immediate mode GUI. That's the idea of this. And then a lot of people have some misconception about like how immediate mode works. Like I said, does it use more energy because it's like rendering all the stuff compared to retain mode and stuff like that. So we're gonna have a lot of fun talking about that. But in order to do it properly, we should each introduce ourselves. And this is often framed as a debate. We're gonna try to maybe here and there structure some questions to have some sort of disagreements. But it's more of a marketing spiel, okay? Like it's actually about a discussion, like ideally sensible discussion. If anyone here in the chat thinks it's like about having a fight between people on screen, don't get your hopes up. But we'll see, okay? We'll see. So first, Nick, can you tell us a little bit about yourself? What's your name? What do you do? And what's Clay?
Sure. So my name's Nic Barker. I am in Australia, if you can't tell from my accent. I've been a programmer professionally for about 15 years. And I have been doing it a reasonable amount longer than that. I've worked across a lot of different industries and verticals on lots of different types of UI. So in what seems to be not as common a case, I've done a huge amount of like web front-end UI programming, as well as now a lot of stuff in C, and I've done native mobile UI programming as well. So I've got a decent sort of handle on how things work in the different ecosystems. And the reason I am on this particular episode of the podcast is because I'm the maintainer of immediate mode UI layout library that's written in C called Clay.
I think during the introduction, you should also mention the programming course that you started.
I mean, I don't want to shill paid stuff. You know what I mean? It makes me cringe doing that kind of thing.
This is what you do like right now for most of your days.
So I'm releasing a low-level programming fundamentals course at the moment that's called The Simple Joy of Programming. And if you Google it, you'll find it. And it basically starts at encoding and machine code and sort of works up to modern programming from there. So if you've wanted to learn some programming fundamentals, you can give that a try.
Nice. Anton.
Hello. My name's Anton. I worked on Dreams, and I did the UI for that, mostly the 3D UI, but also worked on the UI system a bit with Alex Evans on that. And then I worked on Substance 3D Modeler, which is a Adobe modeling package, and that's like a full desktop modeling application, and that's written using the immediate mode GUI system that I wrote for them, and it works in VR. So that's why I'm on the podcast.
Guys, you are on the podcast because we want to have a fun discussion. Okay.
Right. Sorry.
You didn't.
Sorry.
Like there was not like an achievement that you unlock. It's like,
and this is why I've been invited. Yeah. Well, actually, so I brought my Dear ImGui embroidered shirt, embroidered by Omar himself, as like cred. Oh, not actually. Well, it's a friend of Omar's, but so just to establish my immediate mode credibility up front.
Wait, can anyone buy it online? Like, is it available?
I don't think so.
That's a unique piece of clothing. Damn. Nice. And Ray.
Well, my name is Ramon Santamaria. but you can call me Ray. And I've been in the video games industry more directly or more indirectly for the last 20 years. I create in the last 10 years, I've been very involved in education and also create that small library called Raylib. Actually, I also create a second library called ImGui, that it's an immediate mode UI library, but it's not that much popular like Raylib. And talking about my involvement with UIs, I've been very involved in tooling, in creating tools. For the last few years, I developed tools and I published tools. But in the past, I started developing small tools in Delphi back in the day, so long time ago. And then I also developed some tools in Flash, but I think it was an amazing
RIP
tool to create tools. And while I was in EA, I was creating tools mostly for text management and audio team using WinForms back in the day. And yeah, at some moment, I discovered the immediate mode style. I actually discovered it thanks to Unity 3, I think it was, with the ImGui system. And actually, ImGui was a kind of a duplication of the ImGui of Unity, because I really like that approach, that it was super, well, I find it super simple and super handy. And yeah, that's it.
All right. So I think we should start with painting the overview of the retained mode, and then immediate mode, and then maybe some hybrid modes, and like what's out there in terms of, if you would like to program a UI, like a desktop application or any kind of visual application, you need to sort of decide on what style of the programming this will be. And there's a lot of misconception. The vast majority of the applications they're made with a popular retained mode UIs, and this immediate mode is, I think, getting more and more traction. So maybe there would be a volunteer that would like to first kick off with a bit of an overview between these two modes.
I mean, I could kick off the misconceptions, and then I think you guys both have way more experience working with the other things, because I have very little experience working with retain mode. But I think like the main misconception is that people, like, because it's called immediate mode, and if you're not sort of familiar with stuff, people imagine, okay, well, everything like must happen right away at the function call. And so people ask questions like, oh, how about like, does it render right away? Does it do everything right away? It's like, well, the key thing is immediate mode API, right? So it appears as if it's immediate is very different than it is actually immediate. And so the same, like a good analogy is in graphics, like the terminology came from graphics APIs, like the original OpenGL, et cetera. It's like immediate mode, you say draw line, and then conceptually you imagine the line has been drawn, but no one actually imagines that, unless you're like in DOS or something, that the line is like getting straight rastered to your front buffer at that point, right? Actually behind the scenes, it's probably going somewhere else. But if you think in terms of lines, I find it's easier, because it's like retain mode is like, hey, there's a line list and you add lines to a list and then you call draw all my lines, which is sort of the retained vibe. And then the immediate mode's like draw line, draw line, draw line, draw line, draw line. And then the lines got drawn at some point and it's like, you don't know. And so it's really an API question of what kind of you prefer as the mental model to be. And I think just like with drawing, it's easier to think about, hey, I'm drawing this line, then I'm drawing this line, then I'm moving my cursor over here, then maybe I'm scaling, then I'm drawing this line. So you're kind of like almost thinking through how you're going to do things, as opposed to like, hey, let me bundle all my lines, let me bundle all my squares. Like, so in the UI, it's the same. It's like, it's less, here's all my buttons, here's all my things, let me put them in a tree, and more just like, I got a button, and then there's another button, and then there's a group of buttons. And it's like, you just, and then something figures it out, but doesn't have to be immediately figured out. Asterisk, but you know, whatever.
Yeah, just to build on that, it's like one of the interesting things is they're always presented as a dyad, right? They're always presented as you're either immediate or you're retained. So one of the interesting things is like mathematically you can kind of say that like, well, immediate mode should be whatever retain mode isn't, right? And vice versa. You can sort of infer one from the other. So sometimes it's interesting to say like, okay, well, what do the words actually mean, right? And retained mode, essentially the word retain just means that after you've created your UI, you hold on to the data from that creation of the UI. It's like it's retained. And so you end up with data from the UI in the next frame, you know, continuing to live kind of thing. And so what a lot of it comes down to is, okay, you've created your UI. Now you want to modify it. You want to mutate your UI. In retained mode, because you're retaining the data that you've created, it means that you actually need to make a modification to the data that you have. So if you want to remove an item from a list, you have to actually mutate the list and, you know, find the object that represents that UI widget or whatever and actually delete it, clean it up. Whereas with immediate mode, because you can infer that it's the opposite of retain mode, right? You're not retaining anything. So you create your list with a certain number of items. The next frame, you need to create that list again. And then at some point in the future, the list, the data that you're using to create the list has one less item. You just create the list that frame with one less item, right? There's no need to like find the UI object that you created that's been retained and actually delete it. And so that's where I think the actual nomenclature comes from, like the retained versus immediate. But as Anton was getting at, right, like the distinctions become extremely murky because the idea of like, are we using the data again that we've already created and mutating it rather than just like using it once for one frame, one present, and then throwing it away and doing it again. That extends to like a million different places in your application, right? You can make that decision. Am I going to recreate the data this frame and then throw it away in so many different places? Like the most common ones, of course, are like with layout, for example. It's like Clay does immediate mode layout. But you also have like these immediate mode concepts in graphics as well. It's like, am I retaining the data or am I re-uploading everything, redrawing everything, that type of thing. So it's like the reason that it's murky is things can be used like a retain mode layout system and an immediate mode like drawing graphics system, for example, or like vice versa, that type of thing. So like it does get very murky. The distinction, it's like rare these days actually that you have like a purely immediate all the way through the whole stack kind of thing or purely retained kind of. So yeah, it's tricky to pin down.
Well, I also think in that way, like you mentioned, Nick, that the main difference between retain and immediate is that in the retain, in my mind, it's like with classes and objects and more procedural programming style, where you create an object and you got an object with all the required properties stored in memory, and it's there for a certain time. That usually it's more than a frame, but and you modify the data that needs to be modified to then display that data in the screen when it's required. That will be the pure retain mode, and then in the immediate mode, you usually generate, process, and use that data immediately. Well, that's the theory, because then in reality there are many nuances, many things that, and immediate, it's not that immediate, and actually retain could be not that much retain. But yeah, the big difference is in my mind is that in retain mode you create the elements, you create the UI elements, and you keep all those elements with all the required data for those elements, for the state, for the drawing, for the style, etc. You keep all that data in memory, and then you use and modify that data. While with the immediate mode UI, you keep, as you said, deleting and creating the data as required every frame or every certain frames. But as said, it's not that clear distinction, because, for example, for the style, you usually keep the style retained all the time, because it's required for the it requires the font, you require information about the UI style, so that's retained data. But you use that retained data that is usually global, with all the immediate mode elements, UI elements.
Do I have a correct view that usually like the retained mode libraries are very much OP oriented? Like you always create some objects with like methods and then you lay them out, and like immediate mode may be like OP heavy, but it also might be just like set of functions to call.
I made a functional retained mode GUI. It was awful, but you can do it. It's a bad idea. Don't do it. But
how did it look like?
So it looks okay. So I think an easy thing to just be concrete, especially for people who haven't like maybe written a bunch of these. It's like, let's say you want a button, right? You're gonna have to write something like, naively, you will write either something like new button or pull button or get button or make button or some version, right? And so the choices you have as like a programmer is either that creates some kind of object and gives the user a pointer, and then the user owns that pointer. That's kind of like this traditional retained mode version. It's like create button. Okay, now you have a button star, right? And now it's like and then you can actually go either C or C++. You could either say button is pressed, and now you're in OOP land and you've gone down that rabbit hole. Or you can say is button pressed and pass it the button pointer, and now you're in C, but you're, C with objects, not necessarily, methods and virtual inheritance. But in both cases, the user is sort of notionally in charge of the lifetime of that object. I mean, even if we don't think about object, like lifetimes, it's like the library is giving the user an object, and then they could either ask questions about it or call methods on it or whatever. But they're also, at that point, crucially in charge of deleting that object. And so if that object needs to go away, they need to notify the library and say, hey, this object that I have, this button, I don't need it anymore, right? Because now I'm like on a different screen. So really, I think the first kind of checkpoint along that journey is like, who owns the button, right? Does the user own the button, or does the UI system own the button? And so traditionally, the object-oriented ones are like, the user owns the button. Here's your buttons, and then you can say like, parent this to this, and it's like, okay, cool. Who likes managing state? So clearly that sucks. Like just by those grounds alone, you should be like, do I need more state to manage, man? Like, thanks, library. So I think, that's kind of what I think almost immediately pushes people away from that. Now, if you want to manage state for some reason, some people maybe like to do that, right? They want to put their buttons in a list or something. I don't know, whatever. But there is a third awful alternative, which is that you can say, create button, and it gives you an immediate ID. So like saying, I made a button, you don't own it, here's like the handle for it. And that's kind of in between, which is like, you can do all the OOP things and be like, you have the button, but you actually have a handle to the button. So that the library still owns the button, but you have a handle to it. Now you have the worst of both worlds, because now you're in charge of keeping a bunch of handles to ask questions about the buttons, but you can't do anything with them anyway. So it's like you gain nothing. I tried that. It was really bad. Don't do it, but you can do it. It really is, yeah.
Wookash, just to like specifically get it, that like, does retained have to be OOP kind of thing? The way that I think about that kind of stuff is that for some reason, I don't know, I always end up making cooking analogies, like whenever I'm talking about programming. So forgive me, because this is like the first of many cooking analogies that I'm going to make. But yeah, it feels like to me that there are things in programming that are kind of like naturally fit together. So it's like, if you're cooking something sweet, if you're making a dessert, generally the things that you're going to put in there are going to be like either sweet or sour, right? You're generally not going to be putting salty, like savory things into your dessert. Like sometimes a little bit can be okay, but like we're getting out of the bounds of the analogy now. But so generally, like retain mode systems tend to naturally feel like they're supposed to go with like an OOP approach. They sort of naturally sort of push you in that direction because they sort of coalesce together. You don't have to do it like that, but they just sort of attract to each other naturally because when you adopt that mode of thinking about programming in general, you tend to reach for the similar tools in the same kind of way that when you start to do things in immediate mode, you start to reach for the procedural tools. That's just generally why I think like they don't have to go together, but they end up going together naturally because the programmers who tend to adopt one of those paradigms tend to adopt the other one as well. They just feel like they naturally go together.
For an example of a retained mode API that's not OOP, you can look at Vulkan and see how that turned out.
Yes.
Well, I think that it makes sense what you say, Nick, because in object-oriented programming, you tend to think in objects. Well, actually, many programmers tend to think in real-life objects. That I think that's not the right approach of thinking in objects. But yeah, if you think in like real-life objects, you think like a button, a slider. You think in this kind of UI objects, and so it's it's a perfect fit. Object-oriented programming with the different objects that you have. So they don't have to work together because you can have a structure in C with all the data and do retain mode in C or any other language. But I think that most UIs. Retain mode UIs are object-oriented.
It's super tempting too. Like when you're writing it, you're like, I'm going to write a button. And then you're like, oh, I'm going to write a slider. I'm going to write a comp. They're just all like inherited widget. This is going to be awesome.
Yeah. That's
it's going to be so great. And then you just start making files. And then you make in your classes.
No,
and you're like, I'm going to fill all this up. It's going to be the greatest library of all time. And then you just like want to kill yourself.
Text edit widget looks kind of like the drop down, you know? So maybe I can like reuse this part. Maybe I can like a virtual class for this. So it's like, I will share this implementation. It's going to be awesome.
Text edit, it's like the final boss of UI elements.
Oh God, yeah, don't even, we can't even get into text edit on like, really.
Rich text editor, like a UI
but like from the view of a library author, why text edit is awful?
It's not awful, but it's complex. I mean, there are many things to consider for a text edit widget. Control, shortcuts, the cursor position, all the time translating between code points that it's pure data into the visual representation with the glyphs and the cursor. Well, I mean, there are many. I mean, in RayGui, it's one of the controls that it's not fully implemented yet. And I come back to it every 2 years or so, or every 3 years. Okay, let's try to add the word wrap or anything, and trying to do it in immediate mode. With just one function to do everything inside, and it's very difficult. You usually have to do two passes to first scan the text and get certain information from the text to later draw that text correctly.
Yeah, and it's like super low reward too, because people's expectations on text is that it's perfect, but then it just looks like a tiny little text box. But people expect like undo to work within the text box. They expect control paste to work, and like paste is its own thing. Like what happens when you paste like rich text in there? Does it flatten this? Like it's and then people are like, your text box is broken. If you mess anything up, it looks completely Mickey Mouse, and you're just like, what? The app immediately feels terrible if you just mess any one of them up.
Can I let you in on a secret, Wookash?
Oh, now you're gonna tell me that like text field doesn't work in Clay or what?
No. Are you kidding? Clay doesn't have a text field.
You upload this to Raylib, for example.
Yeah, of course. Of whoever the poor downstream is, they have to deal with it. No, the secret is that text fields are so hard to get consistently. Well, one of the reasons text fields are so hard to get consistently right is because people interact with the OS level text fields so much that they expect their behavior to match exactly. And the OS level text fields actually have their own idiosyncrasies, right? So often you need to actually replicate those. And I can tell you that an enormous number of applications that look like they've implemented a text field correctly, what they're actually doing is rendering an invisible OS level text input widget off the screen. Your cursor is in there, and they're streaming the state of that text field out of there. Like for the longest time, like I had a web project a long time ago where I was trying to get some like a decent, multi-line rich text editor working. It was absolute nightmare. And I was like, you know what? The web's like open-ish. The front-end web, at least you can inspect and reverse engineer stuff. I'll go to Google Docs. I'll figure out how Google like solved their rich text editing thing. It'll be great. Go to Google Docs. First thing I find, native HTML input, absolutely positioned off the screen that they have there that just like captures the keyboard input, and they pull stuff out of that and paste it into the document. It's really so difficult to do.
I would add that actually there are not that many text edit widgets libraries out there. I mean, even if you check Visual Studio Code, Notepad, many of those text editors, big text editors, end up using the same. For example, the scintilla component that it's for text edit, it's used by many text editors. The one from Visual Studio Code that I can't remember the name, it's also used. Well, it's the Electron one, I think, is also used everywhere. So at the end of the day, there are not that many text edit widgets out there because it's very difficult to do it right.
Yeah. Modeler uses Sean Barrett's STB text edit internally to handle this, and it, to its credit, works pretty well for like most things. It's not like web dev approved. Like if you tried to do like a proper word replacement or something, like you can't.
Now being a quality bar.
Look, gotta give credit where it's due. Like web text is like way more complex and like sophisticated than game dev text, right? Because game, like, if what we're saying is true, you're like, it's hard to square because every game has like a text field that says enter your name, and then it's like, what, you're telling me that's impossible? It's like, yeah, that's possible, but then it's like between that and like, an HTML page is this huge illusion that you think, oh, and it's just more of that. It's like, no, it's not the same league. It's like, it's a different vibe. And so I think if you want to type non-styled, single font, mostly ASCII characters and have the shortcuts work, STB text edit does the job, but one might think it's easy to extend it past that, and it's just like, oops, you're off the cliff now. You're
all right.
Yeah, and Anton's actually picked up on an interesting point, right? Which is the web does this weird thing to your brain when you work in it for a long time, because it's almost like, compared to C, the things that should be hard are easy, and the things that should be easy are hard.
Yeah.
So it's like you end up developing this like completely backwards perception of like how difficult something is actually to do at a fundamental level on a computer. Yeah. It's like, oh, text input, it's easy. I just put an input element in HTML and I'm done, right?
That's right.
There are so many things like that, I think.
You could probably use this to like, go ahead.
No, I mean that's it's just a perception, but the reality, it's not that. I mean, there are happening very complex things in the inside that really have a very big performance hit that should not be there. I think. And I mean, the perception for the developer or for the user is, oh, look, that's super fancy and super easy to have this kind of text box with Markdown or whatever. But they cannot see what's inside. They only see the front end, let's say that way. And then the back end, it's a complete disaster. I mean, maybe...
If they only knew the pain.
Yeah. Then when you...
But then it's like the... Yeah, it's like the hamburger
in,
factory analogy, right? Like if they only saw how the hamburger was made, maybe they wouldn't eat the hamburger. But like the industry exists because nobody sees how the hamburger's made.
That's it. What I mean.
Yeah, imagine if
every was really happening.
Imagine if every web form for every like government website or whatever, you have to enter your details. Every single case, the programmer had to write a text editor, like a text input field from scratch. We would not have a single website, right? There would be no internet in that case. So yeah,
well,
abstraction is a good thing to some degree.
Maybe it would be a better internet.
Well, yeah, well, maybe. Yeah.
The Soviets tried to not have McDonald's. It didn't turn out really well. Like eventually McDonald's comes whether you want it or not. So
I was wondering whether the Soviets of the Roman Empire was going to come up first in this podcast, and now I know the answer to the question.
Now, I would like to follow on a sort of tangent that happened. In terms of UI libraries and UI programming in general, what are the differences between web and the desktop applications, roughly speaking, right? Like we have like super dominant React library, also like Angular, that is visible in the web. But the web is like about manipulating the HTML and the DOM. And then like on desktop, you're now like rendering through hardware, through GPU, like uploading textures underneath. Like this is like quite different style of working. So like, how do you adapt your model to the libraries of UI, and then like what user should be thinking of when he's programming UI for web and then for desktop?
I would say that the point is that the browser nowadays it's an operating system. Actually, it's an operating system specifically designed and created to render text and display webs. That's it. So this browser already gives to the users a big set of tools and libraries and systems already set up to do that task very well. So even that you can build over the browser Angular, React, and many other libraries. The basic structure, the basic tooling, it's already very it's already set up to make things easier than when you are trying to work for a multi-platform or in a more native way, that you don't have all that kind of structures already set up. So it's way more difficult.
Yeah, I think Nick knows more about web. Nick, you talk about web.
Yeah, I was just going to say, I think when it comes to the level of abstraction that you want people operating at when they're building a UI, for example, I think the important thing is not how high level it is or how low level it is, but the idea that someone could easily move between those levels when they need to. Like one of the things that programmers from the games industry or from embedded or desktop apps have when they do stuff on the web is that it's very high level, and there's the floor to how low down you can go is very high, right? There's a limit to how much you can get into the nuts and bolts that is very, very far away from what the machine's actually doing. But that's not to say that level of abstraction away from that kind of stuff is actually bad. Like you don't want your designers in your game engine to be worrying about, like the quads that are going to end up on the GPU, right? You want them to actually be operating at some high level where they can think about things in terms of like pages and layouts and like reusable components and that kind of stuff. But you really need the ability for someone to like crack the thing open and get down to the nuts and bolts when they need to actually make something work really fast, or they have a particular edge case that they want to fix, that type of thing. And so I think the really important thing is the ability to move easily between the different levels of abstraction, and not necessarily the concept of high-level abstraction itself, if you get my drift.
I think in my experience, limited experience doing stuff on web, like my high-level distillation is that the web kind of came out, or like all of HTML and CSS, it came out from this need to lay out documents in a responsive way. Like the fundamental idea of HTML is like there's some text, but the presentation is going to be driven by the device. Like, and not just in a screen aspect ratio way, but like could be in crazy ways. Like it's a completely different font or whatever, right? Like all this stuff. And when you start from that baseline assumption, which is, you know, how the web was made, the choices you build up on top of that are really different. Whereas games come from this idea that there's a buffer at like OXAA or whatever, and you're running at a real-time rate, and you want to present a coherent image to the user that is interactive in a loop. And it's the same every time for every user because it's made by an artist, and the intention is this way, and the font is this way because it makes it spooky or sci-fi. And it's not playable with a different font, and it's not playable without music or whatever, right? So it's like there's a very artistic bend to it, and very, very much a I own the screen bend, kind of coming from arcade and all this stuff. So I think game developers kind of at a base lizard brain level are always attempting to own the screen. And even in a web app, they're like, give me like at least a canvas. What can I own? Where's the thing I own fully? And in the web, the baseline assumption is I own nothing fully. How do I adapt to what's happening? And I think that makes for like really different mindsets. And so the web is in many ways fighting towards this thing of like, hey, can we get a actual 60 FPS loop that's like not glitchy timing and whatever? And can we get GPU and whatever? But the game dev, there's a similar battle of like, hey, I want to lay out like Civilization UI or something. That's really freaking complicated. There's a lot of bits and games that have to go on mobile or other platforms. Like, hey, I need to work with a different aspect ratio. Like, oops, now my simple UI system that just sort of like types in the pixel coordinates doesn't work anymore. And then you're like, what do I do? Well, I guess I need to, maybe I should divide the space. Well, I'll call that a div. Wait a minute, I made a div, and it's just like Jesus. And so now you realize you're at the bottom of this other ladder, and they're like at the top of the ladder, and both are like trying to get somewhere in the middle. And so I think that's how I kind of imagine it. It's like if you need to do a lot of static layout, the web is your friend. And if you need to do tight interactivity, then game dev is your friend. But if you're in the middle, you're just in pain constantly, whether on one side or the other.
Yeah, and another really, really important point there as well on the distinction is that the web has been completely defined by how small the bandwidth requirements have to be. So it's like it was incredibly important early on that like you could get a complex UI up on the screen. You could basically send a tiny application. Like the web really is like, as Ray said, it's like an OS. And the reason it's become so popular is because it's a system for distributing small applications in a way that's actually sandboxed and secure. That's the reason that the web was so successful, because, you know, from a native and desktop story, we just never solved this issue of like easily distributing secure sandboxed applications. We couldn't figure it out. And the web, they were the ones who figured it out. And so that's one of the reasons that the web became so popular. But yeah, one of the trade-offs for that is that when you're distributing these applications over the internet, and like when the first time I ever tried to program on a computer, I was on 56K dial-up. And when you're on an incredibly slow internet connection, the size of the application really matters. And so essentially every ASCII character that comes down the pipe in a JavaScript file, in an HTML file, in a CSS file, it has to make a big impact. A much bigger impact than the ASCII characters in a C file. Like essentially the higher level languages
Demo
do
scene
more.
in web programmer like Epic Engine.
Yeah. The higher level you go in this stack, exactly, is you essentially get more bang for your buck in terms of the ASCII character in the source file versus the number of instructions that get generated on the host machine, right? And so bandwidth, I definitely think would have played into the design of those kind of systems as well.
So why didn't APL take off as a web programming language?
Someone's going to bring up
now?
Forth at some point.
For everybody interested, Google APL syntax, and then scream in horror, and then never look it up again.
Be grateful for the web you have, because you could have had APL web.
So, by the way, like we mentioned a couple of like different reasons. I recently understood that like Qt introduced like this QML, the Qt markup language, which is basically like JavaScript runtime. That is like you can define your layout in like a markup language that is actually running through JavaScript, which is like for a C/C++ library that is often used for like embedded stuff. We're putting now JavaScript, like what's the reason? Like the text fields are the reason now, or like what is happening?
Designers.
Meaning what? Meaning like you can now design stuff as if you were to design stuff for the web.
I think it's just because Qt, it's because it's C++, you have design, like designers on web can punch stuff into CSS and make like the button bluer or whatever. But in Qt, that stuff didn't really exist. It's just C++. And, the C++ developers don't want like designers touching code and checking that into GitHub and breaking the build or something. So then it's like some stuff you can put into a style sheet and sort of have like a manual file or whatever. But then other stuff, it's like, so QML tries to solve that problem where like a non-programmer could jump in and be like, hey,
Well, actually in video games, I think there are right now a couple of libraries, UI libraries, that use that kind of YAML language, that you define all the UI of the game in a kind of a markdown. No, not markdown. It's an XML style language. And well, I actually think you have some tooling to do it in a visual way, but that tooling outputs some kind of XML file, and then at runtime the engine consumes those files and displays the UI in the required way. So
that's what Adobe.
And I agree that's for designers mostly.
Yeah, that's where all of Unity's new stuff is going. UI elements, that kind of thing. It's all essentially a clone of the
RIP.
It's like the three major sort of pillars of the web, the three horsemen of the apocalypse. It's like the split between the scripting, the structure, and the styling. It's like the JS, HTML, CSS equivalent. UI elements has those like three, that distinction of the three pillars as well.
Natural separation.
Mm-hmm.
But you can also do that in C or C++.
Yeah.
I mean, you don't have to use that kind of XMLs or CSS or this kind of intermediate languages to try to make that separation more explicit and more. I mean, you can do everything in C with different structures and different groups of data and keep it simpler, I think. I don't know why.
It changes what's easy. I think it kind of goes back to that same point of like, if you have that separation, it makes changing the color of a button really easy, but then it makes changing the color of the button based on the value of the monster's health, like kind of having to jump through hoops, right? And so in a game scenario where you're like, hey, I just want like this button to flash red because I want my dude to heal, and like I want to draw attention to the potion button because you're in danger. Like doing that kind of code in HTML kind of sucks, but in games that happens like all the time. Whereas in a web page, like a bunch of people, there's so much code, or like, styling code. you need like 10 people just constantly changing colors of things all the time. And it's like, if that requires a recompile, that sucks too. So they're just like optimizing for different speeds of improvement, I guess.
Different kind of products, different kind of products.
Yeah.
Yeah.
Like, what do you have to maintain? What do you have to iterate on? Adobe Medium, or the Oculus Medium sculpting thing had a YAML-based UI. That's the one that I ripped out and replaced a non-YAML-based UI.
But then, like, if you rip out some of the stuff, like, okay, so the marketing spiel would be, okay, now we have like a language, like a easier thing than like a programming language for designers to use, right? But then it seems like this future never happens, where like you have this like department of programmers that is doing like programming stuff, and there's like department of designers, and there's like a super easy link between them. Like they don't know, they don't even talk right now. Like they're just like, it's awesome. Like they are designing, they're programming, like, oh, it's great. Like it never really happens. Like, do you know of a situation where it actually made it, like the setup where it worked, right? Like, oh, we have made this like perfect layouting system with like anything, and then like you don't need to bother with those programmers. They are smelly and like they talk weird. Like don't look at them. It's like, did it work ever?
No.
I got it to work almost for Modeler. Because that's basically the problem that I was trying to solve with this UI system that I wrote. Because exactly what you're saying is the designers on the one hand are like, they're usually making visual mockups, traditionally like in Photoshop or XD or whatever. Nowadays, obviously in Figma. And Figma has like more reactive stuff, so it's better and blah blah blah. But they're kind of typically doing visual stuff. And then usually you hand that to a programmer, and the programmer has to deal with like, okay, what happens when that actually like resizes on things? And sometimes they have to make some kind of changes in terms of like how they think about the structure of that stuff, as opposed to how a designer might think about it. This is probably a bit abstract, probably like Nick gets what I'm saying, but like how you hierarchize things matters a lot. And a good designer will hierarchize the things like a good programmer, but an average designer will sort of just group things how they want, and a bad designer will make it like in pixels with Photoshop and then just be like, you figure it out how it looks on the phone. Like, I don't know. And so what we did with Modeler's UI is that I made a sort of pseudo language of things like rows and columns and kind of like Flexbox style stuff, but I sort of simplified it and wrote like a cheat sheet. And the designer that I worked with, he happened to be quite a structural technical person, so it worked. I don't know if it would work for a technical person, but he could write in sort of a text file the actual structure of the UI he wanted, and then I would just like copy paste that in the code, and I would change it to C code, but the structure and the main bits, he would do that design. And so that's as close as I got. And I could imagine doing the automatic translation, especially like with AI or whatever. I'm sure you could just like slam it in one the other. But I think it requires on the designer's part some level of structured thinking. That's kind of the takeaway.
Well, from my point of view, everybody should know a bit of everything. I mean, at the end of the day, you're working with a computer, and there are so many parts connected inside that you cannot just focus on one part. And I mean, yeah, you can be an expert of one part, but you at least need to know a bit. Well, you definitely need to know how all the parts are connected, definitely. And I think you even need to know a bit how the other parts work in case you have to change everything. And that level of specialization, oh, no, I'm the designer, I'm not touching anything code-related or code for the programmers. Come on, no, that's not how it should be. I mean, I like coding, but I also like art, and I also like design. And maybe I'm not an expert artist, but I know how the things are interconnected, And if I have to open a 3D model and change something because there is a requirement, I mean, that way of working with very separate experts, it's an extremely slow way of working. Because everything that you need to do small changes, you have to move the ball from one expert to another expert to another expert. And at the end of the day, at a corporate level, that's super slow. That's super slow. So I always think that it's recommended to know a bit of everything. I mean, a bit of everything about the final product that you have or you expect to release. How all the parts work together to get to that final point, even if you are an expert in one specific part.
Yeah, I totally agree with that. I think like having wider knowledge always benefits you in the long run. You don't even notice at the time how helpful it is, but the more that you learn about more disciplines, and it goes the other way as well. It's like if you're a programmer, like one of the things that I found really useful over my career is that like while doing front-end web stuff, I didn't just take the designs that were being given to me by designers and be like, okay, I'll just convert these like pixel for pixel into the CSS representation, that kind of thing. It's like eventually I learned how to become a designer myself by looking at the things that professionals were doing and trying to figure out, like
why are they doing these things?
Yeah, why are they doing this particular thing? Looking at the fine details and that kind of stuff, and picking up that skill has just been like amazingly useful for me over the years. But Wookash, something funny that you might not have heard before is that like this kind of thing of like, oh, we finally won't need programmers, because I know it's like a vibe coding thing now, but that's like the latest evolution of this long line of, Pokemon that of we're not going to need programmers anymore. So early on, people were saying this about text-based like assembly languages. Like when we went from machine code, like punch card machine code to like text-based assemblers, they're like, we're not going to need programmers anymore because normal people can write assembly, right? When we went from assembly to C, they were saying the same kind of thing. It's like, oh, we don't need programmers anymore because look at C. It's so easy that normal people can write C now and they don't have to use assembly. Like one of the biggest like selling points of them inventing SQL, or some people call it SQL. I've always called it SQL. But one of the biggest like marketing points behind the original like invention of SQL, because like SQL is sort of like not like a natural way to interact between two different boundaries of your program that you expect to be very high performance, right? like if you're trying to like go from like a very high performance application into a data, like all your data where you're expecting to do like really cache efficient traversal, that kind of thing, pull things out of a gigantic database with indexes, you kind of don't expect that you've got just like this soupy ASCII based text interface that you're using like to do that kind of thing. And like one of the biggest points behind the creation of SQL in the first place is they're like, we're sick of like the finance people and the higher ups in the companies always coming to the programmers and asking them to generate these reports on this, we want to aggregate the data, we want to do the blah, blah, blah. They'll be able to do it themselves. They'll just write SQL, like the people in charge will just write their own SQL queries against the database. Surely they won't accidentally drop the tables or accidentally do something that creates 40 million subqueries and just like kills the whole DB. It'll be fine, So this type of thinking has happened for a very long time, and I think it comes from this weird. Well, it obviously comes from a misunderstanding of what programming is, right? Like it comes from this perspective of like the hard part of programming is the syntax. The fact that there's braces and semicolons, that's the thing that's hard. That's what normal people don't understand, right? And if we turn that into something else, that will just fix all the problems, right? And it turns out that the syntax is actually the easy part, and the part that actually makes you a programmer is being able to visualize the edge cases of a particular approach in your head and break a complex problem down into simple ones that you can actually attack efficiently and have a good chance of solving, right? Move iteratively towards a solution. It sounds like simple, but it's actually incredibly hard to do. And it's like, all of us, I'm sure, would agree. It's like after a lifetime of programming, you can still improve at those things. You can still see new situations where you fail to break it down into the smaller pieces correctly, where you fail to visualize all the edge cases correctly, where you do all this work and you find out, oh, there was like a critical part of this thing that is just like a dead end. Like I can't get past this thing that I should have visualized ages ago. And I think that's like what the programming mentality is. And so you can apply that to almost anything. And yeah, just making the syntax easier or creating a visual tool is not going to fix those problems, you know?
Yeah, I completely agree with you, Nic. But in that line, I think that what has happened in the last 40, 50 years is that as humans, we have tried to move to higher level in a more human way of thinking about the tooling and the way to do things is starting with Windows itself, with the icons and the folders and all this kind of elements, and trying to move in a more human way to visualize things. But the problem I find is that computers do not work that way. At the end of the day, computers work the same way that they work 50 years ago. So you can try to abstract things as much as you can to make it easier for end users. But at the end of the day, computers work in a very mathematical way. You got data is in memory, you got there a calculator that makes numbers, and data is moved around, and the computer's architecture, it's a very primitive way of working. So I think that moving that into a so human way of visualizing things, it's not good, because you are losing lots of things in that abstraction.
You're losing the self-selection of people who actually want to do this. Like trick them into doing it, and then they realize, oh no.
Yeah, but it has forced in a way. I mean, if all that tooling to abstract the way computers work has been done maybe in another way. I mean, there are a lot of tools out there, like the new debuggers from Ryan, and there are a lot of tooling that pops up every day in the market that it's not so high level for users. Oh no, let's make it very easy for users to abstract everything so users do not need to understand anything. Come on. I mean, we can create tools that do not abstract that much, and users probably still will understand things, how they work in the inside. So, well, I think better software is possible.
Now, I would like to come back to a bit of like immediate mode discussion, or immediate mode focused.
Okay.
Kind of trailed off a little bit, but it was fun. Anton,
I forgot about the whole immediate mode
Anton's
thing.
like immediately
What happened?
out.
Oh no.
Anton, come back. In the meantime, so we started to talk a little bit about the web and how web changes things, and then like how web looks like in terms of like UI, and like how those basic paradigms are changing.
Mm-hmm.
Now, if we come back to desktop UIs and we take a look at the immediate mode UI, is there a situation where immediate mode is strictly better than retained mode and vice versa? Like, is there a way to say, hey, like here you shouldn't do that, it's gonna cause you a lot of pain? Or is it just like a sort of familiarity thing? You just do what you like to do, and like, or is there one mode, like immediate mode is strictly better? Okay, like every time, and you shouldn't use retained mode.
It depends on the
End of
developer.
question. It is, yes.
Yeah, I mean, if the developer feels more comfortable with some tooling that it's retain mode or immediate mode, at the moment, for example, for me, I feel very comfortable with immediate mode. But if I need or I have to create or work in some tool using retain mode, okay, that's fine. I still think that it's better immediate mode, but that's fine to work with one or another.
I'll appeal to like a more baseline principle, which I think is like the one truism of computer science advice, which I think there isn't a lot, is that you always want to reduce state. Like the truth is that like most state mode problems, just at a fundamental level. So if you could ever get rid of state, that's great. State that you manage is always like a source of bugs and a source of difficulty. So the only time to introduce state is for performance. Like that's the memory versus cycles trade-off. Like, and that's why the flip side of that coin is that like caching is one of the hard problems of computer science, because you can never really know when you dump the state, when do you memorize the state, like caching is just a nightmare, right? So I think that's the key. And so if you have the performance, do immediate mode. If you for some reason don't have the performance and you have to retain, well then retain like as much as you have to and then no more than that. And so I think maybe contrary to like the maximum, well, actually, I think it's a caricature to think of like all the C people as like maximum performance people, and like it's not true. Like the reason I do C++ is just so that I have like overhead to do dumb things and still the code is fast, right? Like I can do a ton of really awful code and it's still way faster than like JavaScript and so I think I would start with immediate mode and then optimize like as necessary towards retain mode. And I think what you'll find is that like, you know, you look at Clay or ImGui or all this stuff, or just at least for a baseline in 2025, like we shipped Substance 3D Modeler. It's like a real application. It's a 3D modeling tool. It's non-trivial. It works in VR desktop. The UI takes like 0.01 milliseconds to lay out every frame. Mm-hmm. Like you can do it. Now on a phone, batteries, we can get into that, whatever, but you can progressively cache more and more things. So I think from just that baseline argument of like, one should not cache unless one must cache, I think immediate mode is the correct starting choice. And then if you happen to find yourself retaining a lot, then okay, yeah.
I just say that just for example, in my case, I find it immediate mode more comfortable because I'm working in many products at the same time, and that's a lot of code bases. And I usually like to work in single files most of the time. So files tend to be very long, like several thousand lines of code. And for me, specifically, immediate mode fits better in that way of working. But I can understand that, for example, for a company with 10 people working in a product with multiple files, maybe could be better to have the logic in the retain mode with the logic through events, and then the visual style with other files, so working in a different way. So
yeah, I mean kind of, but you still want the actual logic to be immediate mode, I think. Like even if you abstract away the style, I think even with I would say more so with multiple files, because one of the nice things about like ImGui is that you can just dump the debug files wherever you want, and you don't have to be like, here's my GUI file and pollute that with your debug crap. So I think like ImGui proved that ImGui is way better for just distributed GUI for sure. So I think that's a solved problem. And then I think the style is an unsolved problem to some extent, because I think ImGui sidesteps that, because I mean it's not trying to solve that problem, it's a programmer debug GUI. Nic is like just trying to solve that problem unless it's text edit. But like it's still unclear how you inject style effectively without straight going to CSS. Like I don't know, Nic, have you seen, do you have a feel? I think you were the closest to attempting a full web level amount of styling, or at least knowledge in that world.
Yeah, I mean, it is probably worthwhile to get into a discussion about what styling actually is and like what the landmines are there and stuff. But just to sort of close out the discussion around like whether you choose retained or immediate, I definitely fall into the same kind of bucket as Anton, which is just like I'd go immediate by default and then adopt retained if it's needed for extra performance. And one of the sort of baseline idea that's actually operating there is this idea of single source of truth. It's one of the I subscribe to extremely few like programming principles, right? Or like I'm not really about prescriptive stuff at all. But there's this fundamental idea which is known as like the single source of truth principle, or like the idea of sources of truth in general. To give you like a high level idea of how it works, it's like when you move house, you know how you have to just change your address in like 20 different places and you still get mail to like the old address that the poor next people have to forward to you. That's because your address, as it's like known by like companies and organizations, is multiple sources of truth. They all think independently they know where you live. And there's not a single source of truth for where you actually live where you can just update it in one place. So
that's the way I like it, Nick.
Yes. We're talking about the Soviets again soon. So essentially, immediate mode is an enforced single source of truth. You have your source data that always, the UI always reflects your source data, because when you change your source data, the UI gets deleted the next frame and completely regenerated from scratch, right? So it means that you have one place, you change your data, you know that that everything's gonna look the same. You know, like if you have a username, for example, that's displayed in like 4 places on a web page. It's in the top bar, it's on your posts that are in the feed, it's in its settings menu, it's in blah, blah. You can see it in 4 places on the screen. In a retain mode system, that username is duplicated 4 times into those widgets somewhere. And when you update your username, you have to make sure that you actually hit all those widgets, right, to update your username in 4 places. And you can easily just miss one, and that's because you have multiple sources of truth, right? Whereas in immediate mode, you have functions that produce your UI. They all are based on the same like username string that's just in one place in memory somewhere. And if you change that, the next frame, it's just going to instantly be reflected everywhere, right? So managing multiple sources of truth, I think, is a really important part of programming at like a fundamental level. And the reason that caching is hard, like the reason that we have that adage about naming things and caching, is because caching, by definition, is the creation of multiple sources of truth.
That's right.
You have 2 copies of something, one's faster and one's slower, but the slower one's usually the real one. The slower one's the actual source of truth, and the fast one is the clone. And there are cases where the clone can get out of sync with the origin one, and so that's the reason why caching is hard. Basically, it's a fundamental principle in programming in general. And so I think that the idea is that you start with as few sources of truth as possible, and then when you know things are going to get too slow, that's when you start to
and that's also the natural place to draw your abstraction boundaries, because that's actually what tells you where to, because from the UI systems, they do caching behind the scenes, but you're not aware of it, and you're not supposed to be aware of it. That's like the one true correct use of private, right? Because if you mess with it, you mess up the cache and you actually cause more problems, like without any kind of, there's like an actual truth to that privateness, as opposed to a sort of like, don't look in my room kind of privateness. Like, I think like 100% with what Nick is saying, like, this is the fundamental takeaway from like a lot of programming that I've done, is like, if you can remove state, you will always be better. And then if you need to go faster, oftentimes it's about adding state. And it's like, those are the actual trade-offs. So I think from that principle alone, don't do retain mode, because you probably don't need to go faster in your UI. probably.
Yeah, totally. And like in terms of like what Ray has to talk about like over and over again, right? Like this classic trivial optimization that you make in static UIs that don't have any like breathing animations or anything like that is that when the cursor's not moving and when there's no keyboard activity, you just flip the same buffer over and over again. It's like a trivial way to like cut down on the amount of on the power usage, for example, in a UI. As soon as you've got no input and you've got no animations that are still waiting to settle, you just flip the same buffer over and over again. And like a really interesting way that you can test this yourself at home, right, is a classic thing that people will do is they'll have a Raylib application up, for example, that's not configured to do I think it's called event waiting or something like that is the name of the API. Yeah, they'll have a Raylib application up, and they'll have their like OS's like activity monitor, like performance whatever thing, task manager saying like, look, it's using 30% CPU, just sitting idle doing nothing, and then they'll have the browser up next to it on a page like Google or whatever, and then be like, see, the browser's using no CPU for the same kind of thing. But what they don't realize is that if you go to your browser and you jiggle the mouse repeatedly, the CPU just like spikes.
Really?
Because they're using exactly the same approach, right? They they flip the same buffer over and over again where the mouse isn't moving. But when you're getting input, it's actually a very non-trivial problem to prove that input hasn't resulted in any pixel change to the screen.
Yeah.
Without just recomputing the whole buffer and comparing them, right? It ends up being cheaper to just actually recompute the whole thing and represent. So yeah, it's just like a classic thing where like the ideas about retained and immediate are generally not fully formed in people's heads if they haven't really used both of them in any degree of depth, and so it's easy to not realize like, oh, there's actually trivial optimizations that you can make to immediate mode that are literally a one-liner in most cases, right? That will significantly reduce the power usage, and so yeah, it's a matter of education a lot of the time, as it usually is with most things.
You can also look for more complex solutions to, I don't know, keep some data or whatever. I mean, not only the input events waiting. I mean, you can look for other approaches. For example, that's with animations. If you want to have UI with animations, you can. I got some tool that I do that when something is animated and enable the frame buffer switching, and then when the animation stops, I reset again to the ambient waiting. So, I mean, there are lots of solutions to try to reduce the power consumption, the performance to try to improve.
Totally.
So I think
another tiny tidbit there, sorry, is just like that's one of the reasons why most modern text editors still use a blinking cursor and not like an animated breathing one. Because as soon as you have a pulsing cursor at like 60 FPS, you're generally on the hook for like regenerating the entire screen.
Yeah.
and nowadays, I think I'm not sure about that assumption, but it's impossible to use some kind of like the dirty rectangles back in the 80s and the 90s.
Oh, no, nobody ever does that kind of thing anymore.
That's impossible to do nowadays, right?
Yeah, I think it's not. But you're going to still slap a whole buffer and
yeah.
Maybe like using the variable rate rendering VR extensions. Some ungodly. So like after writing a couple of these systems for Modeler, because I actually ended up writing either 2 or 3, and 2 of them were like awful. I think I came to like my succinct definition of what makes it immediate mode, and it's related to what like Nic was just saying, and that is that at the call site is the only time the state is modified. So the versions that went sour for me is like, it's tempting to somehow be like, well, you know, you have a button, but maybe I want to handle the button click later, or maybe I want to handle the slider change later because now is not the right time in the frame to update it. And so you bake things into your UI, which is like an update callback. And it's like you can have an immediate mode UI with all the callback hell of a retain mode UI. You can actually build that. I've done it. It's bad. And so if you defer the state change, it breaks the happy mode of immediacy. And also, if you defer the input handling from anywhere else, you lose this sense that you understand when the state is happening. So I think the two keys for me are the input is applied at the call site, whatever that input might be, and then the state is changed at the call site and nowhere else. But the rendering, the layout, all that stuff, you don't care as the programmer. Like the logical thing you care about the programmer is the state mutation and the input handling for like latency and things in games.
All right. I think there's like one still question that is being discussed in the chat and also like not really explored. And you mentioned a lot about performance and differences between like immediate mode and retain mode. But maybe some of you have done like actual experiments to try to have the same UI in both versions and sort of verify this for like how much of the performance hit you have, because like everything will take up some energy, right? Some like CPU cycles. Is it like a huge cost, or is it something that is like really like minute and you kind of don't need to worry about it? Because like there's a discussion like caching, CPU, GPU, like people are still trying to like wrap their head around it, like immediate mode rendering too fast, too much every time.
It's too fast.
Too fast.
Yeah. Go ahead, Ray. Sounds
Okay.
like you might have done it.
Yeah, actually, with that small library, RayGui, when you have to create kind of big tools or complex tools, placing all the controls manually, all the widgets, it's a pain. So I created a small tool that it's called UI Layout. That it's a visual tool that you choose the controls. It's like
Visual Basic, yeah.
Basic or Delphi approach that
Delphi,
you got
yeah.
the palette of controls and you choose the controls and you place the controls. And actually, that's kind of a immediate mode working in a retain mode.
Yeah.
So I got a structure, a very simple structure that is just the rectangle, the type of control, and some basic states. And I can design a full UI placing the controls I want. And that's it. And actually, then the problem there is how you export that retain mode UI into, again, an immediate mode UI. And the way I do is to export generate code. That's the way I do. I just create C code, and then it becomes immediate mode again. But I also got the option to export a list with the controls and information about every control placed, like the rectangle of the control, the state of the control, the type of control. So if I want to keep a retain mode UI, I could load that list of controls in my program, keep a basic structure for all the controls, and have a kind of retain mode UI system based on an immediate mode UI library. So it's possible, and in terms of performance, keeping some extra data for each control, retain extra data, it's not that expensive actually. It's like, I don't know, 24 bytes per control, or I don't know, 64 bytes per control. That's nothing.
Yeah, I think like, okay, I can give you some raw numbers. I'm just thinking in my head of like all the things that you're going to have to do to do UI, whether it's retained or not. Like anytime there's a mouse motion, you're going to have to raycast against all your widgets. Let's say that you're going to have 10,000 widgets. Like when I spoke to Omar about like performance stuff, just rehashing what, I'm not going to speak for him, but when I talked to him about this, he's like, probably the largest Deer ImGui usage he's seen is about 10K widgets. Because just practically, if you stick more than that onto a screen, it's just like a nuclear power plant panel, right? And so unless you're literally making that, at which point, I don't know, probably doesn't have to run at 60 hertz. But like, Anyway, you have to basically pick some sensible amount, right? Because otherwise it becomes this odd discussion of just like, I render 4 billion nodes. And it's like, dude, who cares? It doesn't matter. Like if you agree that at all you want to trade CPU speed for, let's just call, I don't know if, I don't want to say productivity, but like, I think we've established that immediate mode will produce less bugs and make it easier for you to write the code. Now, we're not going full web here, you know, but if you give me 0.1 milliseconds, I will make your life way easier, right? And so, okay, if you're going to say, no, I'm on the play date and, you know, I'm writing it in C, and I know Clay's like on play date.
Clay
anyway.
runs on the play date. So
yeah, Clay runs on the play date already. So you already know where I'm going with this. But like, if you say, no, 0.1 milliseconds, can't give you that. Like, I'm on the Amiga, man. I'm a demo scener. Like, I don't know. Then you could start to say, okay, well, you're going to have to hit test every time you move the mouse. Like we already talked about how you can only do things when the events happen. Already you can do that. So it's not about like you're running all the time. You can render only when things change. So we're not talking about rendering all the time. None of those things are the immediate part. But you will have to hit test your elements. The question is, how much is your hit test going to cost against your 10K elements? Whether it's retained or immediate, you're going to have to walk. Let's say you make the cleanest retain mode version and you have no allocations. You're not like new and deleting nodes. You make some arena. You push all your elements into there. You're not doing inheritance. You got the most awesome, fast retain mode thing. You're still going to have to walk that list and test most of those things or make a BVH or something, right? Like, I don't know what you're going to do, but so that's there. And that's probably about like 0.05 of the milliseconds, right? So the next question is getting the event back from the system. So you want to be told that you got clicked, right? Okay, well, you're going to have to register some callbacks somewhere and so on, so on, so on. And like you're fighting for probably a 10th or 100th of a millisecond to win here, I think is sort of my feeling in terms of the logic. The rendering is separate, but the rendering is like its own thing and can be fully separated. So you really like maybe ask chat, how much do you care? Truly, are we really fighting for 100th of the millisecond? Because we could talk about it, and there's like stuff you can do there. But I think there's stuff in there that you have to do for both. The main thing where you lose sort of waste cycles is that in an immediate mode API, you're running through that whole declaration in your function call stack. And so for every one of your things, you have to sort of notionally kind of add them. That is actually pretty fast. I mean, it's not instant, but it's not as bad as people think. For example, on Modeler, we don't even do any hashing. So Omar does CRC32 for the strings for every ID, and he's like, it's never shown up on the profiler.
Yeah,
but
we
like,
do as well.
Yeah, I was in that camp of chat. I was like, I can't do it, man. It's too wasteful. Like, why? Can't they just all be statically hashed to an int? So we don't do any hashing at runtime for Modeler at all. So you can do that if you're really scared. And then really it's a case of like mostly compares against one or two nodes to figure out where you're at. So it's a question of either there's a polling happening for every node, basically. That's the cost. It's walking n nodes. And typically your n is going to be like 1,000. It's not going to be 10,000. Like, unless you're like looking at this Riverside app, it's probably like 600 at most. You know, so it's the cost of walking.
Don't underestimate the web, Anton. There could easily be 100,000 divs on this page.
There's
you will
stuff
never
you
know.
can't see.
There's a text editor on the side that I'm not aware of. That's a full rich text npm package.
so for the modeler, you needed to put this on VR, and then you kind of like you're in the kind of mobile area, and it's like, oh, about energy and battery and like was like immediate mode an issue, or like you had like
in VR, it's a complete non-issue. Because in VR, all of this falls apart because you have to render the whole thing every frame anyway. And you want to animate almost everything because otherwise it feels really dead in your hands. So in VR, you're starting with the baseline assumption that first off, you could be animating at any point. In VR, you have to take the worst case because you never want to drop a frame. So if you can be animating, you have to be animating the whole time. So you might, like, it's all about fixed costs. And so it's totally fine. And Dreams runs on top of immediate mode GUI as well. And that runs in VR on desktop. So It's a good flat cost approach, actually. You'll never have a spike because you're always kind of touching everything. Yeah.
No, I just want to say in that sense is that computers are super fast, and when it's true. And when it comes to just do basic math to calculate basic things, that's extremely fast, even for low-end devices like a Raspberry Pi or very low-end devices. And the costly things that could be more graphics related with processing pixels nowadays is moved to the GPU. So the GPU is doing that. And I mean, if just one simple, lighting shader for a pixel, if that had to be done in the CPU, would be probably one order of magnitude more costly than processing thousands of UI elements.
Yeah.
So
yeah, and actually, Nick and I had a funny conversation where we both commiserated that the worst part of GUI layout, if anyone cares to guess, Nick knows.
But we're talking performance-wise, like
performance-wise, number one thing off the charts by far is measuring text length.
Yeah. So if you want to render like a complex GUI, and you're writing like a layout system, and it's all immediate mode and stuff, like if you're concerned about the cost of like walking the tree of nodes to figure out the layout, to get the layout to settle or whatever. If you don't do caching, the cost of just measuring how large the text is going to be on the screen is going to be like 90% of your whole budget.
Yeah.
It's amazing how expensive it is to figure out how big non-monospace text in a particular sizing is supposed to actually be visually on the screen in pixels, because it has to go through the entire font system, right? Through your entire text rendering system, basically.
Which might have fallbacks for different languages, for different fonts and italics, and oh god, like...
Yes. And so, like, you have to cache that stuff if you want to get reasonable performance of like your UI layout system. So it's like you've almost like introduced a concept of retention there from the outset, right? Like in Clay, we have to hash every string, measure it once, and then cache the measurement of each of the words, because then we can do wrapping without having to remeasure anything. But yeah, it's interesting. When you haven't worked on the nuts and bolts of one of these systems, your assumptions about where the bottlenecks are going to be, where the hotspots are going to be, are often quite off base, you know?
Yeah, I actually that I got a small tool that it's a text editor that... Well, it's a text editor. I never publish it because there are so many text editors out there that I never publish it. And one of the things I did for the text editor is I keep the lines. I got a structure that keeps a pointer to every line in the text, in the main buffer text, and the length and the size in using the style. Because that was the most complex thing, to get the code points from UTF-8 and get the using that the font, the width of every character and everything, and that was actually the more costly process. Yeah,
we had like a scare on Modeler because I kind of a little bit YOLO'd the immediate mode thing because people were like, can you do this in production? We're using ImGui, but I was like, no, it's totally fine. And like, so we did it and everyone's like, is this gonna work? And then like we were doing stuff and working on it, we weren't paying attention to it, but I always had like a CPU timer always watching, kind of, and then one day like I open it and it's like 2.3 milliseconds for layout, and I was like, oh shit, like it's happened. And it's like my worst fears have occurred, I'm about to get fired. And then like I start profiling it, and it turns out that like someone added UTF-8 and like text sizing. Before we were doing like a naive, just like we didn't have multi-line, and so whatever. So I had like my own little loop counter of just like how long something is going to be. But then we added like a real font library, and then I started doing the performance, and it was like it was completely all text, like 98% of the performance was text. And so after we cached the text, it went back to like 0.01 again. And I was like, okay, cool. Like we're back. We're back.
I'll let you in on a little secret. So like there's this little like, it's like a psyop that you can do on people when you're building a library. So if you have a part of your like pipeline that you know is going to be insanely expensive, like text measurement, for example, what you do is you make your library with and you say like, oh, you know, we have this great like flexible setup where you can hook your text measurement into your own engine, and then like you can do it using your own machinery. It's really flexible. You just override this function pointer. Because then later on, people are like, oh, it's super slow. And they profile it. It's like, oh, it's my code. It's not the library. it's my code. So it's like you can cleverly like outsource responsibility by saying like, oh, it's flexible. You can override this part of the system. You know, like there's a, you know, you can swap out the modules for the other ones. Yeah.
But
you can also
firewall it off.
Do actually anyone use those kind of hooks ever?
Well, I mean, that's how it's written.
Yeah, the way that we did it in Clay was essentially we were like, okay, the whatever like backend that does the rendering is also responsible for the text measurement.
Okay.
Yeah.
So for example, if you use the Raylib backend in Clay, it like hooks into the Raylib text measurement function.
Okay.
As part of like, so the
You
first
get
time
the
you run the text, it'll call Raylib's.
Okay, I see. It's my fault.
It's actually funny, Ray. I actually ended up writing. There's essentially a hot path that doesn't use Raylib's internal, the publicly visible text measurement function for if the text is only ASCII, it can make like very sweeping assumptions about.
There was a hot path inside Raylib for that.
Yes, exactly. So it's like, because UTF's really hard, and if you don't have to use it, you shouldn't. But it's like a classic trick to do. It's extensible, and also it's your problem now.
I need to tell you that Omar is in chat now.
Oh, really?
Wow.
Coincidentally, he spent the day optimizing the text related to large buffers. So like.
Checks out.
It's classic. It's one of the few cases in which I really feel like you really feel how old C is doing this type of thing, because you just can't realistically do compile time hashing. In my own projects, it's trivial because I just do code generation. Basically, I just parse my own C files and I just swap out the IDs for the pre-hashed versions that I do with a external tool. Like I actually just like edit. It essentially just edits the C files. But when you're providing a library, you can't do compile time hashing. It's not like something that's achievable, and so you have to eat that cost at runtime, which can be quite significant if you're looking at like, you know, one of the things that you can do, because Clay supports like text wrapping and all of that kind of stuff, you can just render a giant scrolling document. Like you can render a document with 100,000 words in it into a scroll container and expect to be able to smoothly scroll the text. And in order to do the layout, it's like you got to hash that gigantic bit of text at runtime, which becomes a problem if you're doing it in immediate mode every frame. Whereas in other languages, like basically all the modern languages have a compile time hash thing just built in, and it'll just replace it at compile time and you'll never have to pay that cost. But it's one of the things where C is a bit long in the tooth there.
There are really awful macros you can use for like strings that are up to 31 characters or maybe 29 depending on the compiler that you're using.
It's like it sort of half works for IDs for short IDs, but for bodies of text where we use that hash to essentially cache the text measurement. Then I mean, I think it becomes problematic.
The safe like takeaway is that if you're doing something with text, you're going to be paying for text really,
Yeah.
above anything UI related, because like in any real app as well, you're going to have localization probably, right? So you're not even really passing in strings, you're passing localized strings, which have to get expanded to blah, blah, blah. And you might have multi-language and all this real world stuff, which means that you're never really able to do compile time anything anyway. You're in the world, right? And so then when you look at that performance cost, you're like, oh, I'm making a real app where I have 10,000 UI nodes. What matters? It's the text, because I'm dealing with text, and that's the thing that's eating me alive right now.
Totally. And we've come full circle now, back around to that same thing. The web makes things easy that really aren't easy underneath, and it makes things hard that really aren't hard, right? Like the fact is you can dump an ungodly amount of text into Chrome and still have it perform really well in a situation that would really hit the like edge case degenerate path in lots of other UI frameworks. Like they've really thought hard about how to do that kind of thing, and it just works pretty seamlessly, to the extent that people just don't really think about it. Like devs don't really ever think about text on the web as being a
thing to solve.
A big performance boogeyman that you're worried about, like, oh, we got to make sure that we don't have a degenerate case here kind of thing.
Well, it's kind of interesting, because I think that's also, people were asking like what retain mode things are useful. And actually, like, I will give text to retain mode because you can perform these optimizations behind the user's back. Like the scrolling list is a canonical example. Like Dear ImGui, all these libraries will have some kind of way for the user to call the text, because that's the other slow thing. So like Nic will give you a pointer to size your text, and Dear ImGui will give you functions to call your text, because it can't. It's inefficient to give all that text to ImGui for then to throw all of it away and then do that again next frame. So that's a place where retained mode implementation starts to collide with retained mode usage, because really as a user, you want to give it a pile of text and say, look, chew through this, retain it how you might. I think there's some ways you can hash the text and maybe retain. So what we do in modelers, we actually end up having a side cache of text things, but like that's the night. If the UI wants to handle it, that's nice.
You can have a solution in immediate mode that balances some retained data.
But how do you know that the data? Like, how do you know you've got a cache hit? Right. That's kind of the question. So like let's say you have an immediate mode, let's say you have an immediate mode like body of text, and it's like 100,000 lines of text. And on frame one, I say, hey, render, some Soviet novel.
Yeah, okay,
from
then
Nic.
on frame one, you will have to do that cache of data. In frame one. But then
in frame two, you better hope the user hashed that text too, so they give you the hash of the text. Otherwise, you're going to at least have to hash the text to know that you have the text, right?
That it hasn't changed. Yeah.
That it hasn't changed. So
that it hasn't been mutated in place. Yeah.
So in Modeler, we take the same thing as like Sean Barrett's thing of like, you own the text object. You don't even pass us a string. You pass us the text object. And one of the operators that's handy is to have an equals. And there's like a big old comment saying, look, we're going to check equals a lot, so you better make sure it's fast. Good luck. Yeah. so yeah, I think that's exactly right. But then it requires something of the user. But again, any production level system will have that anyway. Your string will have some kind of, you'll need to care about that in places other than your UI, probably, right? Like if you have a production grade string class or whatever you want to do, it's going to want to do this kind of stuff anyway. So it's kind of like, if you care, you care. And if you don't, well, you just stub that with a string compare. And it's like, you still aren't probably going to see it on the profiler if you're not a real app.
Would I be able to talk about this like specific canonical example where retain mode is actually much easier than immediate from a developer API perspective? Because
it's
like
gonna be blood
censored.
Let's go. Let's go.
So the classic thing that always comes up with a retained and immediate mode is animations, right?
Oh, yeah.
UI animations. So this is like a very, very common point of contention. One of the things that the web technology makes really easy is animations. I actually love the CSS transition API, and Clay's like layout animations are like based on the CSS transition API, right? And I think when it comes to animations, it's important to realize that there are sort of like different classes of things that have different levels of difficulty, right? And it's like there's this ascending sort of levels of difficulty involved in animations. The easiest animations are animating an existing element, the properties of a single existing element. So like you're animating the color of a button, right? Yeah. And then animating the position of one element, the absolute position of one element to one other place on the screen, right? That's sort of like level 1. Level 2 is assuming you're using an auto layout system, like Clay or the one on the web, something like that, animating an existing element from its current position to a new position that's automatically determined by the layout engine. Right? Because now you don't have a reliable from and to, like target position from target position to target position, right? Like if you swap the order of two elements in a to-do list and you want them to like animate like this, rather than just like suddenly swapping, you want them to like smoothly animate like a switch like that. The layout engine needs to know that
positions.
It's the same element that's actually swapping positions. So in an immediate mode system, a naive immediate mode system, that's very difficult because if you destroy all the data from the last frame, you have two laid out UIs, right? One of them is in the new order and one of them is in the old order. And the system, in a naive sense, has no way of identifying whether the elements have changed order, like whether those are the same or whether they're different, right? So they end up just snapping across one frame. So the way that we solve that is by introducing some kind of IDs, essentially
IDs
equivalent of retained data, right? We tag the elements with IDs and we tell the layout system like, hey, even though these elements are in opposite order, they actually match to the elements that were in the original order in the previous frame, right? And then so you can start to do animation. Not too difficult to do that type of thing. So that's sort of like level 2. Level 3 is where you want entry animation. So it's like I add a new thing to the list and I want it to animate in, right? So now you need to know like not only the ID of the element from one frame to another, but you need to know when an element didn't exist in the previous frame. And so you need to actually detect the case, okay, the element didn't exist, and now I want it like, I want it to appear with like 0 opacity and then like animate in or expand out or something like that, right? Then level 4, which becomes exceedingly difficult for immediate mode, is I want something to animate out when it's removed, right? That is a really big problem in immediate mode systems, because the frame afterwards, the way that you express things in immediate mode is you just have a loop that goes over your items in your to-do list and you just render them in the list with their IDs, right? And you expect like, okay, if they change order because I'm tagging them with their ID, the layout system can figure out that they've switched. It can use the fact that it had no ID the previous frame to detect the entrance, and I can do that animation. But the problem is when something exits, you need to actually retain the data for that element until the animation is finished playing, which from a data perspective is like long after the data's actually been removed from the list, right? So now you need some like back buffer of elements that are like fading out or something like that, and that becomes like really, really messy, and you end up with a sort of retained mode system underneath your immediate mode system if you want things to actually work nicely. And it's one of the reasons why when you may or may not have noticed this, but around the Flash sort of days of the internet, doing animations on websites was very common. Not just on Flash, but in HTML as well, right? People did CSS animations all the time. Like so many websites would just like... And there were little pieces of animated things that happened all the time. And when React came in, suddenly all the animations disappeared. All the websites became static. And the reason that happened is because React is an immediate mode API on top of the DOM's retain mode API, and it has really no facility naturally for dealing with these types of animations.
You can check out anytime you want, but you can never leave.
Yeah, right. And so don't even get me started on the fact that now they do server-side rendering in React, which is technically the web server is an immediate mode API that calls into React, which is an immediate mode API that generates DOM, which is a retained mode API, gets sent over the wire to the client, which then gets rehydrated with React. React attaches over the top of that, which is immediate mode API, over the top of the retained mode API, which is DOM in the browser, right? So you end up with this just like layer cake of stuff, right? But eventually there's some like packages that sort of do fakery with React animations, like for exit animations. What they do essentially is, because React is immediate mode, but it's over the top of the DOM, which is retained. Essentially, they just pull that node out of the immediate mode hierarchy and just keep it in some back buffer, positioned with its absolute pixel coordinates on the screen. So it's not actually in the hierarchy. It's just pretending that it's inside the hierarchy. But yeah,
how
essentially,
does it keep the data? Does it copy all the data too?
Yes. Well, I mean, it just moves it around.
All garbage collected and ref counted anyway.
Yeah, exactly. So it wouldn't be actually cloning the DOM element, I don't think. It would just be like, it's technically just moving it. Although there is an enormous amount of cloning that happens in JavaScript, because so many of the APIs are immutable. Like they'll return a copy of something with the modification rather than mutating in place. But yeah, so animations are something that becomes progressively more difficult in immediate mode. But, right, here's the big caveat. I think one of the reasons that people find animating things so difficult in immediate mode is they're so used to a retained mode API in which, because the retained mode API owns all the data, right? When you do like when you want to do an animation, right, you say animate from to, you have some API that you poke, right, that the retained mode API provides for you for doing animations or transitions. Whereas an immediate mode API, if you think about it, it's already animating. It's always animating. It's rendering to the screen at 60 frames a second, right? It's always animating, right? It's and that's the thing that takes people a while. It takes people a while to click, like, oh, it's always animating. So like, I can literally make a float, right? Yeah. For like the opacity or like the color multiplication of this button background color, and literally every frame I can just modify the float and it will look like it's animated at 60 FPS, because it is. Yeah, like that's the whole thing. It's totally like fine. Immediate mode's representing every frame, so you can literally just do animation by mutating the data that you're using to generate the API every frame. But it doesn't click for people usually that they can do that, because they're expecting the API to be some kind of like, I call a function that animates from this position to this position kind of thing. So yeah,
you can also have two floats, like one that you're setting, and the one that is like smoothly animating to match with like easing in or easing out.
Yes,
right?
exactly. You can totally do that kind of thing as well. But you can do whatever you want because it's always animating, right?
But then you need to store all that data. You need to store at least the final.
Now the user has to deal with it.
The counter, the easing type. You need to store all the animation required data. But in that line, I got one question. Why? Web, I understand that animating things could be kind of fancy, but in desktop applications or in applications intended for productivity, why you need animations? Really?
That's a very good point.
Why? Why you need that button to change the color with a fade or to pop in some way? I mean, really? Really?
Why do you need 5 flavors of ice cream? There should just be one ice cream.
I mean, vanilla, chocolate, that's it. You don't need more.
What flavor is C in this analogy?
Yeah.
Ray, I can introduce you to like a couple of product managers. You have like a heated debate.
Really, sincerely, in terms of productivity,
no, you're right.
Anyone has ever measured the cost, the mental cost of the people using those tools when you see everything like blinky, fading, and I mean...
Yeah, no, you're right. I mean, that's why I think a low-key reason why people like Dear ImGui is there's like, I'm back in the DOS days where when I click things, they immediately click and none of this hover floatiness. Yeah. So, I mean, I will say for VR, you begrudgingly want to have some transitions because when you're on the desktop, I totally think you're right. And I think it has to do with the fact that when you click a mouse, there's this immediate like click that you want to happen. But when you're in VR, you tend to have like more like a trigger and also sometimes a motion. And so it feels weird if you click and everything just goes, it like anytime you're dealing with the real world, it requires a little bit of, and so I think that's also somewhat true for touch. So I think where I think designers are not wrong is that with touch, it does feel better to have some smooth reactivity because again, it's this physical thing. So I think if you're in keyboard and mouse world and gamepad, maybe gamepad like a little bit, maybe with joysticks, it might feel a little bit. But yeah, it's another one of those 100% things because transitioning out is the reason, is a massive reason why we have like complexities in the modeler thing. But because you can imagine images, right? Like just imagine you're making a game or whatever, and it's like user shows up a help pop-up or something, and it has like some helpful diagram, and you're like, yeah, open pop-up with this image, and it like loads the image. And then it closes it, and you're like, what happens to the image? Like, who owns it? Is it copied every frame? That's insane, right? So we just provide an API for that. There's an image type you override, and it's like, if you want to copy it every frame, we're going to value copy it. It's C++, and we're like, override the value copy operator, implement reference counting. It's your world, man. Statically allocated. I don't care. We're going to call the copy operator every frame. So, like, good luck. And so, yeah.
In a very slight defense of animation, I will say I think there's only one case in which it's appropriate in pro-level tools. So any animations in pro-level tools, I always try and turn off, right? So if I'm doing music production, if I'm editing video, if I'm doing programming, anything like that, I want like 0 animations. Just turn them all off, please. But there's just one case where I feel like they do provide like useful visual information. It's like, imagine if you're playing like an open world game and like the game wants to like alert you to a character talking to you like from behind or something. Like you're playing some mainline Zelda game, and the classic thing where some guy's like sitting on a roof and he's got like the wheat thing in it coming out of his mouth, like, and he just like talks to you out of nowhere. The camera like pans from where you're looking up to the character so that you know which way you're actually facing, right? So it's like it doesn't just snap instantly backwards. Link's head doesn't just like suddenly rotate on a bizarre angle like in one frame. And that's because like when you're changing the orientation of someone's viewport, it's really important that you don't do it in a way that conflicts with like their natural understanding of like, humans can't turn their head like instantly, right? So our perception of like movement is based on that kind of thing. And so the very small animations that you see in stuff like Rad Debugger, for example, like one of the things that you do in like code editors or when you're looking at disassembly or that kind of thing is you're jumping around from point to point all the time. And one of the most useful pieces of visual information is like, did I go up or down? It's like, I don't know even what direction I went. It's like when I go to definition, it's like, did I go up in the file? Did I go down in the file? And so like the slightest like 50 millisecond, maybe 100 millisecond max animation to just give you an indication of like which direction you actually went is kind of useful, and I actually rate that type of thing, but it's just been so abused that like when I see any kind of animation in pro level software these days, I'm like, ugh, straight away, let me turn it off. Like,
really interesting, because like it made me realize something just now, that if you have a text editor, you actually, I think, want page up and down to be instant, because you know which direction you're going and you just want to get there. But if you do a code search, you actually want it to do a scroll, because you want to know where the hell did you go. So
yes, exactly.
That's true.
There you go.
That's true. That's a good one.
So if Nic happens to write a text editor, just because he might.
So much of it's based on the intention of what the user expects to happen. It's the same kind of thing as like, I feel like interacting with software used to be like this process of mental pipelining. Like you'd have like 3 or 4 shortcuts that your brain was thinking of doing all like one after another to achieve some outcome. But now I feel like programs are constantly like just like intercepting your ability to pipeline stuff with like a pop-up randomly appeared, or it tried to autocomplete and it auto-completed the wrong thing, or like it, and yeah, the disruption of like your sequence of expectations is like a modern thing that I don't rate. And like animation can really do that kind of thing as well. If things animate too slowly and the new window doesn't like gain focus quickly enough,
affects the productivity.
Mm-hmm.
It's a distraction.
Absolutely,
it's a distraction.
Yeah.
Okay, we've been going for 2 hours now. Okay, well, I think we have like at least an hour of like questions. We have now like questions from the audience. So my general question is, how much do you have energy? Do we do a break? Continue for like an hour? Are we slowly ramping it down? Nic?
You know me. I could talk under wet concrete, is like the saying that we use in Australia. But it's
bathroom
up,
break
up to
and
the
then
others.
get back
I
into
can
it.
continue. No problem.
Yeah.
Okay, so let's do it. Let's do a short break, and then we'll probably stay for like hour, maybe hour and a half. It's gonna be a long video afterwards then.
Okay.
But
Like
I can't guarantee that I won't fall asleep in the break because it's 5 a.m. now here.
7.5 minute break.
Oh, that is too long.
I just need like 1 minute.
Yeah. So
I'm going to be slapping
whenever-
myself
2 minutes.
on camera for the next 7.5 minutes to stay awake.
Mute the mic. Turn off the camera, because I'm not turning the stream off. Okay, so it's very important. I'm gonna be back in 3 minutes, so I'll be like doing stuff.
Okay.
And
Maybe play a video
you
for Nic.
come back. We'll play a video if he just like loses it. You know what? I think that like we already spent a lot of time discussing some of the stuff and your libraries and like Substance Modeler and Raylib and Clay was mentioned a lot of times, and like how it works under the hood, but we didn't like devote a couple of minutes for every library to actually describe what it is, what it's doing, how it's doing. Clay is, for example, an interesting one with like bring your own renderer style. And Raylib and Clay can like work as a one thing. So it's maybe for a lot of people might be very useful to actually spend some time and understand how is everything working. So like Nic is falling asleep. Nic, are you there? Nic.
I'm thinking. I'm not asleep. I'm thinking.
Can we get a short overview of Clay?
Sure. So typically UI these days in the modern world, not always, but typically it uses some kind of automatic layout algorithm. So rather than saying, I want these 5 items in a list to be at these exact pixel coordinates on the screen, you use some kind of API to define, I have, a container that lays out its children from top to bottom, and I'm going to put the 5 list items inside here, and maybe the list items themselves are containers that have like a small photo and some text laid out left to right kind of thing. And the idea is it handles all of the edge cases for you, like, okay, what happens if there's not enough space in the container for the text? It should wrap to the next line, but what happens if the wrapping makes the container taller? It's like, okay, the next things need to be pushed down, and the outer container needs to get larger, and that kind of stuff. So UI layout libraries essentially take your a hierarchy of UI that you've defined. So the defining thing about them is that they allow you to nest things inside each other, and they use that hierarchy to figure out where your UI elements are going to be on the screen and how big they're going to be. So they compute size and position for you. And one of the interesting things is that historically, layout has been a black box buried like quite far down inside other UI systems. So it's like on the web, there's no real way to like access the layout system as like a standalone small thing. It's like you got to basically use the whole browser if you want to use CSS and HTML's like layout system. It's been similar for other UI systems in the past. And so I just wanted to essentially build just that component, the auto layout part of a modern UI system, and have it be standalone so that you could just plug it into whatever environment you want. So it doesn't do any rendering. All it allows you to do is define a tree of a hierarchical tree of UI elements, and then it figures out how the end result is supposed to look. And it gives you a bunch of controls of like, I want this much padding, I want this much gap between the elements. I want them to have this maximum and minimum size. I want them to grow to the size of their container or shrink to fit the contents, like all of that kind of stuff.
And you do inputs too, right? Not just layout.
Yes.
Right?
Yes, we have like rudimentary input handling, but you can actually just avoid all of that stuff if you want to. Yeah, so that's where it fits sort of in the scheme of things.
Clay C layout for Bam. This is incredible.
Once it clicks, it clicks hard.
Oh my god, it's like
I got it before, okay? Like, I'm not that slow, okay? I'm not that slow. But it's awesome. I wanted to.
So many people have said that. It was literally the first thing that I thought of.
Like, smart.
You're just so much smarter than us, Nick. That's why.
You have an amazing video on like going what it is to actually do a layout, like mathematically what you need. So like if anybody is interested in this, look up Nick's video of like layouting, like a tutorial, and also beautifully animated as always, available on YouTube. And third thing that I want to mention, for the hardcore viewers of Wookash Podcast, all three of you, there was a debate with Ryan and Bill at some point in the past. And Ryan mentioned a C for loop macro trick.
Oh, yes. Okay. Classic.
There is a macro trick that you can do.
Defer for loop.
You can make a defer statement with a for loop. And before this discussion, we realized that this is exactly what is happening in Clay to help out with layouting. So maybe you can briefly mention this, because I think people will appreciate this.
Sure. So just at a high level, if you're not that familiar with C, a macro is a very simple mechanism that allows you to replace some text with some other text before it goes to the compiler, right? So it's just sort of like a straight text replacement. And so you can sort of build interesting things with macros that you can't really do in the pre-processing features, or rather the sort of structural features in other languages. And so one of the really interesting tricks that people have come up with that someone else showed me when I was originally making Clay. So a classic problem that you want to solve when you're constructing a UI hierarchy is, how do you create an ergonomic way for defining a container and then attaching children to the container, like putting children inside the container. So you basically want to say, I'm opening my container here. What usually ends up happening is you have a function that says like open container, and then the children might also be open container, do some stuff. Eventually you close the children, and then you close the parent. So one of the tricky things about this is that it's very easy to accidentally forget to close one of them or close it in the wrong order. And then if you close your container too early, the children will get parented to like the next container, or if you close it too late, you'll end up with children that were supposed to be somewhere else parented inside a different thing. Can be very hard to debug what's actually gone wrong. The UI can just look totally wrong, and it's hard to like actually figure out where these things are supposed to match. Like you can do some trivial sort of error checking, like do I have the same number of opens as closes? Like you can at least balance that type of thing, but there are subtle ways that you can get it wrong. So the solution that a lot of different UI libraries sort of adopt, like the one that they have for React, is called JSX, and the way that it works is you basically use HTML tags, and you say like I'm opening a tag, and there's a paired thing where everything between the open and the close is automatically parented, right? And so I wanted to achieve that kind of thing in C. The sort of API that I wanted to have was like you define an element, and then you have like a scope with some braces afterwards, and you put all the children in there, and somehow they're automatically parented to the top level element that you've opened. And so the way that this trick works, C doesn't have a defer statement yet. There's one in proposal, not for C23, but the next version. C doesn't have a native defer statement, so there's no real way to say, open this element and automatically close it for me like later. And so the way that this trick works is it exploits the fact that when you have a for loop, you have for, and then you have traditionally the definition of the iterator variable. So you have like for int I, and then you have the loop condition. So it's like I is less than the length of a list, for example. And then you have the iteration, which is the increment, which is like I++, for example. It's the common thing to do. And so the condition runs before the loop, and the increment runs after the loop. And it turns out that you don't have to just put I++ in the increment, right? You can put whatever you want in there. You can say I++, comma, call some function. And if you do that, that means that the function will be called at the end of the for loop after the body of the for loop's run, right? You extend that trick a little bit further. You extend that trick a little bit further, basically by saying, I only want one loop iteration. So I is equal to 0, I less than 1, for example. So it'll run a single iteration, and then if you think about it, the increment, the function that you put after the increment, will only run once after the body. So it's technically functioning like a defer statement. Then what you do is you wrap just the definition of the for loop, not the braces, just the for and then the parenthesis. You put that into a macro, and the macro takes two arguments, which is like the body, the open and the close. So it's like what to do before the body of the for loop and what to do after. And you just inject the before into either the definition part or the comparison part of the for loop, and you put the after into the increment, and then you use that macro, put some braces after it, and then put whatever you want as the body, like inside the braces. And so it'll run the open function, it'll run the body, and then it'll run whatever the close function was afterwards. And that gives you like this, I'm not going to say poor man's defer. It actually works really quite well. But yeah, one of the parts that's like hard for it to click is that the macro is only replacing like the definition of the for loop and not the braces. And so the user of the macro can put whatever they want in the braces. And the best part is because the braces are just a normal body of a for loop, it still works perfectly with a debugger and that kind of thing. Like you can step through the lines inside. It doesn't expand into one like giant god awful macro. Like the macro only replaces just like the for loop definition. But it's a neat little hack. And so we use that in Clay, like the main Clay macro where you define a UI element. You use the macro, put the element config there, and then in the braces afterwards, you put the children. And they'll automatically attach because the open and close of the parent element is at the beginning and the end of the for loop body. So kind of a long-winded explanation, and it's like I could have done this in like 10 seconds if I had like a visual guide. Like trying to like conjure this image of like, imagine a for loop, you know. It's just like
So actually, silly side question that just occurred to me. In the original C89, if I remember right, it's going to complain at you that the variables are getting shadowed, and that's like potentially illegal. Because like your inner for loops are going to have the same sort of hacky secret eye or whatever, right? What do you do there?
That's very true. That is very true. And it actually still complains in strict mode in C99 and onwards. So the way that we got around that in Clay is we have a global variable latch that's used by all the macros. It's just an int that just flips between 0 and 1.
Hey. Okay.
And so rather than defining a new one for each loop body, it just references that one instead. But yeah, it is actually something that you have to do. It's still a problem. Yeah, if you use the strict mode with warnings.
Unsolved problems in computer science.
I wouldn't personally care. Like when Ray would know about this. When you make a library in C, the problems that you have to deal with that you would never deal with in your own projects.
Yeah.
Like the combinatorial explosion of compilers, the flags that people like to use. You have to solve the platforms. You have to solve every possible case. You know, whereas with your own projects, you're like, I don't care about that. You know, the compiler's outputting a warning. I'll just use the flag that turns off the warning. Thank you.
And actually, most of those problems are hardly ever found by users. I mean,
there
are always side cases, very special situations. It's, oh, come on, really? You know what implies to support that specific casuistic? Really?
I think that's a great segue to Raylib over here, supporting so many platforms, especially the older ones. So
many things.
Ramon, can you give an overview of Raylib?
Well, actually, Raylib it's a small C library with a set of functions to do many graphics related things like draw things on the screen, but also manage inputs, manage windows. It has functionality to manage textures, 3D models. Well, it's a multimedia library, let's call it that way, in C, but it's just a list of functions that are useful to put graphics on a screen, I think, I would say. But it combines very well with other libraries like Clay or even ImGui, because it provides to those UI libraries the layer for inputs and drawing. That actually an UI library is the only thing it needs mostly. Actually, I got a UI library that is a ImGui library that internally uses Raylib for the input management and the drawing of the different elements. But actually, even ImGui can be used in a standalone mode if the few functions to read inputs and draw rectangles, text, and I think that's it, are provided externally by some of the library.
Rectangles, text.
And then over the ImGui, for example, has no layout. So even there could be another library, another support library to manage the layout system, because basically the layout system is getting measures for rectangles or placing rectangles in a canvas. So, well, not basically, but kind of. So yeah, at the end of the day, all those libraries are somewhat interconnected, but they can be used independently. For a UI system, you only need some library to get the inputs and draw the output. So, and that can be Raylib, or actually can be any other library.
But it often happens to be Raylib, and a lot of people are actually having a lot of fun using Raylib because it's very simple. You can get to use Raylib very quickly. It's written in C, it's very portable. It's easy to get your hands on Raylib. There's an incredible library of examples available publicly, and the entire library is open source.
And growing a lot
Nice.
lately.
And
Nice.
because Zozin talks about it constantly.
Well,
And it compiles sensibly. Like
it
you
was
can actually
originally
compile
created
it.
for. Sorry, Anton. Oh no, I mean it was originally created for education, and that was the idea of keep it as much simple as possible. And it seems that worked really well, surprisingly well, in current world of complexities. So
Just like Python. Python is also a language made for to teach like programming.
well,
It was
actually,
adopted
there is
so
a
widely.
Python binding for Raylib that is also there is Raylib Py that is actually also quite popular.
Who's binding who?
It's funny, Ray. It's like I actually made Clay for the same reason in the first case, which is that I put all this effort into like figuring out how to do Flexbox layout decently for a personal project. And I was like, wow, that was way more annoying than I expected it to be from the outset. Yeah, I just like in the first case, it was mainly from the perspective of like trying to teach people like where the landmines are doing layout. You know, it's just the kind of thing where like once you figure that stuff out yourself, you're like, this actually isn't that hard, but there are a lot of holes that you can fall into. And the main important thing is knowing, you know, where the landmines are rather than, you know, having some galaxy brain level of intelligence. It's like you can actually learn this stuff, you can figure it out, but it really helps to have someone show you, like, if you go down this path, you're going to waste 6 months, like, figuring out that it's not viable. Like, yeah.
Yeah, you can imagine. I mean, Raylib was a weekend project. I thought, well, okay, put some graphics on the screen. It can't be that difficult. And it's been 12 years working on Raylib. So, yeah, actually, it's a bit more difficult than expected.
You also mentioned that like Raylib core set of functions is like 20, and this is like 95% of usages.
80. Yeah,
Okay,
the
like
80
80
core
functions.
functions are the
And
most
now it's like
used ones.
more than 500, if I remember correctly.
600, so I think,
Yeah.
around 600
So
now.
like the tail of functions grows, but not linearly with usage. You know, like it's
No, and
the usage
actually,
will be
I
there.
try to avoid adding new functions. I mean, my best days are when I remove functions and I remove code. and I lately, for the last few years, I've tried to move a lot of functions into examples or into separate code to try to shrink Raylib API. But there are always things that can be added or are required. And the point is that for the last few years, I've been developing tools also. And when you try to develop products to put them into the market, you realize what you need. And that's a problem because that function could be useful. Or I need that function for several projects. Okay, let's put it in Raylib. And it kept growing in that sense. For example, in the last few years, I've been adding lots of functions to manage directories, manage files, lot of text management functions, these kind of things that sometimes you need depending the project you're working on. I find myself needing that kind of functions, and I kept adding them into Raylib. And actually, I must say that at the moment, if you compare the Python file system and text management functionality, it's quite close to what Raylib offers. Really.
Well, I think actually
it's going to turn into an OS. Like,
Yeah, it's wow.
This thing you're describing, I think, happens to a lot of these things. But I think one great thing about Raylib and why it's sort of remained popular, in my opinion, is that you've avoided the trap of globbing it all into one fat binary that sort of you have to buy into. Because as soon as you do that, somebody like any of us looks at it and be like, oh, Raylib, it's just got too many things that I don't need, like all this text stuff, and I just don't need that. And then they do the weekend project that you did, like over and over and over, because nobody wants the bloated version, but like you do need the bloated version also, right, for like actual work. So then by keeping it, like, I think, just praise on the job you've done, like walking that fine line, because I think that's the golden ticket, right? And yeah, without that, you just get another one of these things that is giant, but
Well, it's not that big actually. It's not that big, because I don't know, the library itself. If we do not consider the external libraries like the STB and similar,
right,
it's about 15,000 lines, something like that. No, maybe not that much, even lower. So it's not that big. Actually,
so
I think.
so what you're saying, 15,000 lines, you're saying someone could vibe code that in 2 hours is what you're saying, basically, right?
Maybe in 2 days, not 2 hours.
Now, Anton, unfortunately, Substance 3D Modeler is not open source, maybe yet, but you spent a lot of effort to maybe on a different level, instead of still making a UI, but for a product, right? Not for a library that will be open sourced. So how was this different, and how the library UI looks like for a product? Like what you needed to do, how it looks like. You mentioned immediate mode a couple of times. Where were the trade-offs and stuff like that?
Yeah, I mean, the main thing is so Modeler is in VR and on desktop. As soon as anything in VR is in VR, like you basically get carte blanche to rewrite everything, because nothing works in VR. And so, that's
the dream.
The dream, right?
But I have to make it from scratch, like I can't do it.
What are you gonna do? You're just gonna render it to a flat quad and display it? Like, come on, this is not. And so, and also just realistically, if you try to use, our options were a lot of the retain mode systems. Like I think some stuff at Adobe runs on Qt, some is on internal Adobe stuff, some is on Electron and stuff. But none of those things, if you just do the basic thing of just like expanding a panel in VR or adding things, the amount of reshuffling that happens, first off, it's like at best it's in a separate thread and it's not stalling your main thread, but like all the reshuffling that you take an Electron app and resize it just looks crazy. So you can't have that stuff in VR. Again, can't is in quotes. Like you could make a really janky VR app, but we wanted to make a good VR app. So we're like, okay, in VR, the baseline assumption is that you have to animate everything every frame because of these effects and transitions. Like it's kind of fundamental. So we started there, and I worked with Omar at Media Molecule. So that's how I learned about like immediate mode stuff. But then also for Dreams, we had an immediate mode UI system, but actually it didn't have layout. So maybe that's an interesting technical thing, is you can have an immediate mode. And I guess that's how ImGui is, except with the additional libraries that are existing now. Mm-hmm. So you could have any flavor of these things. You could just have an API which says, put a button here, put a button there, and you basically do ad hoc layout in a loop and be like, so Dreams was written basically like that. It's all ad hoc UI layout. Oh. But the reason is it's targeting 16 by 9. Like, so you don't have to do anything. Like maybe it's a different resolution, but it's 16 by 9. So effectively, and in VR, it's just taking those panels and putting them on your hand in whatever aspect ratio. And then maybe there's some hard coded things. So we started Modeler in kind of a similar vein, kind of, not by accident, but Modeler was always meant to be on desktop, but we naively as game developers just kind of thought, we'll just rescale some things, like it'll be fine. And so we started with kind of like just a fixed version, ImGui, but could animate. And then we were like, okay, it's getting a little tiresome to do these animations and layouts. So we adopted something more like Dear ImGui, where it's like, oh, you just add buttons and it sort of like does the auto layout, right? And that flew for a little bit until kind of like real designers showed up and they're like, I want margins and padding and like borders and this. And I mean, they're right. It looks not great from like a typesetting perspective, right? Because it might look good for a programmer, right? But then if you want actual designers, they're like, hey, we want like a little bit more spacing here, but then like here we want some spacing, and then but then down here we want like more spacing because this button needs to be like accentuated, and like you look at it and you say, yeah, no, you're right, this does look better, right? So then when you hit that point, you say, okay, I'm tired of typing in all these freaking margins and padding everywhere. This is insane. So there's like a threshold point that I think games don't actually have to hit, even if you're at the scale of dreams, because you're working with a fixed ratio. And even on PC, maybe you're, whatever, like unless you're trying to support ultra wide, I don't know, where you could just kind of assume a lot, and that makes your layout a lot easier to write. And also you just don't quite have the amount of UI. And so, yeah, maybe if you change your layout, you're like, okay, I'll just change these like 5 for loops. It's not a big deal. But if you've got like 35 functions that you're managing and you're like, hey, let's change the padding on all these things. It's like, okay, well, then you pull it out into constants, but then you get a big constant. Basically, there's a threshold where the amount of work you're doing sort of manually and simply, it no longer pays dividends. And so I think it really just depends. I don't want people to come away with a message like, oh, I'm making an indie platformer and all I need is like an option screen. I better write Clay. It's like, no. You just do the for loop. Like just do that. It's fine, right? But I think Nick's totally right that basically as soon as you get into like a real desktop app where the window has to resize and not go completely bonkers, you're going to naturally write something like Clay because you'll just be ripping your head out, like maintaining all the code without it. So that was like the third iteration of our UI system on Modeler, is like we wrote, I sat down and basically asked some designers, like, what do you want to do? There's rows and columns, and then eventually like arrived, I never read the spec, but I arrived at basically Flexbox, like some set of Flexbox things, and then wrote the thing. And then I saw Nick's video, somebody linked Nick's video, and he's like, here's how we do it. I'm like, that's how we do it. That's exactly what we do, like almost to a T, except it was actually cleaner in Clay because you separated like one more step that I didn't quite galaxy brain through, which is like positioning or whatever. So anyway, I think from that perspective, using this immediate mode stuff for like an actual large desktop app, you end up needing different things than if you want to just do a game but still have a nice UI system. And the input management and even hit testing and text and image management, all those things just basically have tiers, just like Nick said. If you don't need animation, you can remove a lot of code. And so that's where the complexities come from. So it really is this gray area of what is it that you're going to make. And Clay is nice because it covers quite a large swath and it's still pretty simple. But yeah, I like this approach that you bolt things on as you need them, and you don't like buy into for the Qt or something.
For the VR version, is there something fundamentally different? Because like you've showed us like the screenshots of the VR version, and like kind of looks desktop-y, I would say, the UI. Like, so it should be like bigger, or like is there a room for like experimentation in terms of like a structure of the UI that would be different and more like native to VR?
Yeah, that's like basically the way the UI is structured is like for every kind of sub panel or subsection or panel, there's just like a function, just like an ImGui UI function or any of these things. And then in places where we feel like, oh, this would benefit from like a nativization in desktop or VR, you just put an if statement. It's just like global if VR, call this function, and they're all just like suffixed VR. And it's great because you just like you can incrementally put that in. No one has to like, you can just flip it over when you want it. And it's great because the data, like the shared or the single source of truth is still the data, and the data is sort of still separate, and you don't have to worry about that stuff. So
you clearly didn't read the book about like inheritance and like virtual and like different implementations, like clearly.
So we do, and I think there's maybe a difference between Clay. I don't know about ImGui, but I didn't use inheritance for like the elements, but we did use templates and macros, which is probably like an ungodly. It's gonna take flack from both sides. But basically, there's like structs for each pseudo widget, like button or text input or slider, and that's just a descriptor of all the stuff. But I got tired of like putting the same crap into every one of them, and the header got really long. So I just have a macro where it's like, here's like the common properties, and it just blasts those properties. And then here's like the popover properties. And so I macro include those things into each struct definition. And then to like initialize the structs, because there's these weird overlaps of like, well, the buttons and sliders kind of have a shared initializer, but then the text and the icons have some shared initializer, but they have their own. Like all that stuff that you typically do with inheritance, I just have templated functions, which is just like init stuff that's button-like template, and then it just hopes the fields are there, and like it won't compile if there aren't. So like I'm using the tools that I have given.
Anton, can I tell you a small like side note annoying thing about C that's like directly related to the idea of like putting the struct fields in, like macroing in the struct fields. So essentially, like because the preprocessor works on just text in C, it means that you can do things like have a variable that you pass into the compiler, a define that you pass into the compiler that will actually change the layout of a struct. It'll like change the data, right? So it means that, you know, it's a classic thing to do in your own little projects when you have like some widget that you want to extend. You're like, oh, I can just include it and use a macro to like stick more fields into the struct. And the very first version of Clay was like amazingly useful. Like we had this, because I intended it only to be used with C at the beginning. Like we had this thing where it's like, oh, there are these defines that you can like override before you include Clay that will like insert new fields into like the config for like rectangles and stuff like that, or for text. And then it will just transparently pass those structs through to the renderer.
That's how modeling.
So you can get like type safe custom, almost like generics, like type safe generic custom config kind of thing.
Great.
But there's like the most annoying wrench that you get in there, which is that if for some reason you need to mem compare two of those structs, right? You need to figure out, okay, is the config the same from the last frame or is it different? It's actually impossible to do in C because the spec says that the padding between struct fields can have any data in it.
Right.
So the mem compare won't.
But why do you need to mem compare? Just assume it's different every time. Like,
we don't mem compare. This was the case in which I wanted to determine whether things had deviated from the default or not.
Right.
So essentially, are any of the fields in this struct defined?
Yeah.
You can do it with mem compare if you control all of the fields and you can carefully eliminate all the padding or specify all the padding to guarantee that the struct will actually be zero from top to tail from a memory perspective. But if you allow other people to define things and inject struct fields in there can just be garbage between the fields in the padding that will screw up your mem compare or your hashing or whatever. So it's just like a pet peeve. I spent like 2 days like trying to figure out some heinous way of avoiding this type of thing that involves some really yeah, exactly. I managed to get some approach half working where I like poisoned the stack memory with zeros before the user called their function that defined, that like initialized their struct. And on some compilers, it actually works.
I'll just say if I was to librarize...
Just don't allow it. That's it.
Well,
Why
yeah,
do you
we had to
need
take it out. We had to take out the extension
Yeah.
because
That's
it wasn't something I could figure out how to support. It was too tricky. Yeah.
Yeah, and to wrap that up, I would actually also take it out if I was to actually ship the library as a library, because it actually sucks from a developer perspective to step through these macros and shit. But it's very convenient when you're like rewriting this massive library to just be like, slam some fields in here, because when you're rapidly iterating. But once you know what you have, I was actually tempted to just go and clean up and just flatten all the macros, because it's also nice. You look through the header and you're like, oh, I can see the actual fields in this descriptor. Blah, blah, blah.
Yeah, we just moved to like classic user data pointer instead.
Yeah, that's what my home stuff uses, like the stuff that I wrote at home. So the neat thing is that on the one that I rewrote after for homebrew stuff, I also ripped out the input handling. So in a similar way that text and image handling is ripped out in Clay and in Modeler, in my one I also ripped out the hit testing, because that turned out to be another place where some like really custom widgets want their really custom hit testing. That was always a pain in the ass. But then I figured out how to make the IDs work so that the hit testing is externalizable in a nice way. So now all I have is a library that just does layout and just does his testing and just does text, and they kind of glob together, and I think that's the
just as a side note there, one of the really interesting things, like a while back you mentioned like hit testing, and like unless you want to build a BVH for hit testing, you gotta do this stuff. The interesting thing is, in a roundabout way, a UI layout hierarchy kind of is a BVH. And
almost, unless your pop-ups are kids or
Well, yes. So essentially, for people who aren't sort of familiar with the terminology, we're basically talking about acceleration structures that allow you to quickly figure out whether a point is inside a particular like polygon in 2D in this case. So we're trying to figure out, okay, which UI elements on the screen is the mouse cursor like currently over the top of, and in a naive sense you just have to loop through all of your UI elements and try and figure out, okay, do bounce testing on all of them in just a linearly through the array. But if you have a UI hierarchy, you can start to do stuff like, okay, I have two panels at the top level, this container's laid out left to right. So if I bounds test and the mouse is inside the left container, I know it can't be inside the right container, so I can cull that whole part of the tree. And then you go into there and it's like got a million elements like laid out top to bottom. And so you can literally like binary search, like you can put them, you can test the element in the middle and say like, is it above or below the cursor?
Yeah.
If it's below, I can cull all the elements that are after kind of thing, and you can end up with just like something like sub 10 kind of actual bounce checks to find any element in an even insanely complex hierarchy. And then, as you said, like pop-ups are a problem, but luckily we have them as different trees, so we just hit test each tree separately. Yeah.
So I messed it up because my pop-ups are children of the node that popped them open, which means I have to recurse into all manner of nodes that are completely separate. So I think your approach to pop-ups is correct. I will put a slight asterisk on your point if it can't be in the left or in the right. When you're in VR and your UI has depth and it's a pancake and you're hitting with an oblique angle, all bets are off and you have to do like a 3D BVH. And so I just don't. I just go through all of them.
That's when you're rotating the diorama to the angle it's not supposed to be looked at from, and be like, oh, that guy at the back's not got any pants on, like.
And also if you implement any elements that have custom hit testing, that might just spill over. Like, actually, I think what you're saying is very true for kind of production pro UIs, but I think for game UIs, often you have really wacky stuff where like, you've got like a circle, but the sword and the potion are like hanging outside the circle and crap like that. And so
you don't want them to, totally.
Yeah, so I found that actually like, and that's another place where, again, like we're talking about how awesome auto layout is, but really like Clay and my thing, they solve auto layout for rectilinear things. As soon as you want to start doing things that are radial or like on a spline, it's basically custom code, and like you can fit that stuff into a box, and that's kind of handy. But like Dreams had layout that went on a logarithmic spiral, like with all the bubbles, and you scrolled it. And so it's like at that point, you end up having to write like a custom layout hook, which like custom, and then you're like, you want to go back to the for loops. So you got to kind of also judge, like if your UI is going to be kind of crazy and wonky, you might actually be better off like not attempting any kind of layout or a very different style of layout. But like if you're thinking of rectilineal panels, then it's kind of a different thing. That's another reason why I think game developers often do their UI and they're like, I don't want to do any of this CSS stuff. I just want to move the health bar like to the left, man, like to the left. Because there's some head thinking you have to do to put your stuff into these hierarchies and talk about like, well, is it going to stretch? Is it going to grow? And you're just like, I don't care about any of this. Like my thing's never going to resize. So it's like, you know, don't mess with it if you don't need it. It's just going to give you extra headaches, I think.
Now, we are gonna move into Q&A from the audience now. There is a special panel where people were submitting questions, and so I will mostly get them from the most upvoted downwards. I think we'll probably like go for like 30 minutes and then close out the stream. We've already stretched a lot, both like time-wise and effort-wise, I think, for everybody. Now, there will be one exception. I will call out the question that is not from the top for the beginning, because I've seen it all around already on chat, in the question zone, in the comments back on the podcast episode. Now, the question is, does Nick know he looks like Edward Norton?
You know what? That's the first time anyone's ever said that to me in my life. I have never heard that before. Not once. I'm not being sarcastic at all. This is the first time.
Seriously?
Very enlightening.
So the irony is I've heard that a lot about me.
Oh, really? Yes,
No,
I've heard that many times, including
you
like...
You cannot say like, I'm not sarcastic when you're sarcastic, because then it's confusing. So you've heard it.
Of course, yes, absolutely, of course. To the extent where when I have my hair cut in certain ways, like people feel like they need to tell me like on the street. Or like the bus driver or like stuff like that. And it's like, it's always funny because like I try to be friendly to people in general, right? And so if someone random talks to me, I'm generally like smiling as the first point of contact. And when they say something like that, I'm like, you know, no one's ever said that to me before. That's funny. I'm like, sometimes as a joke I say, I'm sorry, I don't actually know who Edward Norton is. Like
Have you tried saying I am Edward Norton?
Yeah, it's just one of those funny things where I think I know a lot of people say this. I think I have like, you know how like when they were first releasing like the very primitive like machine learning stuff, like way before like all AI came out, there were those websites where it's like, this is the face of like everyone on Earth that's been like averaged together into one person. I think if you took like every white dude in the world and averaged the face, you would get me. Because like people, I don't know, like I have this thing, like it's almost like an in-joke at this point with like my friends and my wife and stuff like that. Like people who I've never met before are like, have I met you somewhere? And whenever it happens, the person I'm with laughs because they know that it's going to happen at some point. They're like, oh, I feel like I've seen you somewhere before. It's like, maybe you've probably seen Edward Norton. But yeah, it's just one of those weird things. Like I have some face that reminds people of other things. I don't know what it is and I can't really explain it, but yeah.
I'm glad that we covered this, okay? Really important, especially to the UI programming discussion and debate. Now, on to the serious question. How do you approach supporting accessibility features, especially screen readers, with immediate mode UI?
I'm happy to kind of take this first because I've covered it in lots of different spaces. obviously accessibility started to become a much bigger thing. I think firstly it's important when you're talking about accessibility, like if you're someone that wants to talk to the maintainer of a framework about accessibility, you should be specific about what you actually mean, because it's an extremely wide range of things. I found that people unfortunately these days use the word accessibility interchangeably with vision impairment when they're talking about like accessibility in software. It's a much wider range of things than that, but people generally mean, does it work on a screen reader when they say the word accessibility? So being more specific is like a good thing in that kind of case. Like, can you drive the interface with voice doesn't necessarily mean that you can't see the interface, for example. Just means that you can't interact with the keyboard or the mouse in the same way that other people can. And generally, the way that things work is that the operating systems these days have a pretty good like coverage of range of accessibility features. And so the best experience that you're going to be able to get is using the operating system primitives, regardless of whether they're immediate mode or retained, right? So Swift UI on Apple systems, for example, feels very much like an immediate mode system. You do the same kind of thing. You have a function that takes data and spits out what the UI is supposed to look like. It's immediate mode by the sort of wide, wishy-washy natural definition. But if you use all of the native Apple components that ship with Swift UI, so you make a Mac app that really looks like all the other Mac apps, for example, that will naturally work with the Mac speech-to-text features. It'll work with the voice commands and that kind of stuff. So the important thing is actually not the paradigm, but how well it hooks into the features at the OS level, because the OS is where the accessibility actually happens. And it's one of the reasons why the web has been sort of okay, like not great, but like getting better in that direction, is because it's such a comprehensive environment, and they generally hook quite well into OS level things. Like the browsers are pretty good at using the correct OS level API for everything, not just for accessibility. So yeah, I'd say the distinction doesn't really happen at the immediate retained boundary. It happens at are you making a completely custom app where you're just spinning out essentially like an image to the screen and you're not hooking into any of the native APIs at all? That can be done either with retained or with immediate mode. So the distinction's not really there. It's somewhere else.
Yeah, if whoever asked that has like a clarification about which specific part, because there's like basically different answers to how do you navigate with a keyboard without necessarily having the widgets or whatever, or how do you input text, and they're all just basically different bespoke problems. So yeah, it'll be a while if we just talk about all of them, I think.
Okay, I think this was nicely covered. So next one, how would you guys go about implementing a rich text editor in immediate mode?
Cry first. Step one, cry.
Ray's already done it.
Word wrap.
Yeah. I think nobody has already done it. That's the right answer. For example, for ImGui, I try to do it with the text editor component, or the text editor control, and it's not finished because there are many things to consider that are not possible. I tried to create, as I explained before, a small text editor tool, but I created my own solution from scratch, and it was kind of retain mode, because I pre-process the text and I get the lines, I get the size of the lines, so I get a lot of retained information to be able to draw the text and manage the text correctly. Also to manage the inputs, shortcuts, hotkeys. There are many things to consider. It's difficult.
I think the main key is like because text. It depends on what you mean by GUI, right? Because like Nick's mostly talking about layout, I think, when we're talking about Clay. And we've already discussed that you can separate text layout completely from the GUI itself. So sort of a non-question for Nick, because it's like a text editor that has no UI in it. That's just text. That's not a UI question at all. I mean, like glibly, right? But you could separate these things. And so in order to like, I don't want to give a non-answer, but I would say that like the key reason I would go back to why people like immediate mode and what's been successful and popular about it is this idea of like single authoritative state. So whatever you write, if you just hold on to this idea that we're going to have one place where the state is managed and we're going to have kind of a logical place when it's updated, that stuff's not deferred and kind of happening all over the place. If you just do that, you'll naturally arrive at something that smells immediate mode, as opposed to building it up from objects and then figuring out how to piece it together. Just write it in a sort of functional style. And if there's data that needs to be retained for text, that's fine. It's not like, you know, it's not there's no state. It's just that there's like the one state. So if I was to do it, I would sort of imagine there's a text object and then you pass it in and you operate on it and it comes right back out and it's valid right after that function call. It's not sort of like in some indescribable state. So
yeah, totally. So absolutely agree there. I'd say it's like, how long is a piece of string, really? Because if you imagine building up a text editor from the simplest, like the platonic ideal of a text editor, right, is a single character in the center of the screen that changes when you press a key on the keyboard, right? It's technically a text editor. There's a big A there. When you press B, it changes to a B. Yeah, great. We've got a text editor, right? And then you take it from there to like, okay, I've got two characters. I can move the cursor around between them. That's a little bit more complicated, right? And then you think, okay, well, if I do it in monospace, it's like much easier because I can compute the row column position of everything. So like monospace text in a single line with no wrapping, reasonably easy to achieve. You can do it with a small amount of code. And then it's like you go from, okay, well, maybe we have multiple lines of monospace. So we've got to deal with line breaks. We have to now think about cursor movements going like up and down from one line to another, but it's fine because like the columns all line up perfectly. Then it's like you go from monospace to non-monospace, but still ASCII. And now you have like, you don't have columns anymore. So it's like when you press up, you have to measure into the line of the text above and figure out the best place that the cursor is going to sit when you press up or down. Selection across lines is now becoming much more difficult to figure out the start-stop points for rendering, that kind of stuff. You go from there further to supporting languages that have diacritics and you need variable line height, or you have rich text styling, so you have like larger fonts on some lines part of the way through some lines, different fonts like mixed in together. And then like the final boss, of course, is like also supporting right to left mixed in with left to right. It's like there's like these levels at which text editing becomes harder and harder and harder.
Ligatures, I mean,
yes, exactly. And
goes
so
crazy.
Exactly. And so like one of the things, again, I always plug this really good article called "Text Rendering Hates You." If you Google it, it's a great read and really elucidates like all the problems that you can have. But yeah, it's one of the things that the web does like really well. Like it just provides you these text boxes that just magically do all these things. It provides you the final boss text box with like a one-liner, and that's the thing that sort of like puts people's mind into the wrong place when it comes to figuring out the actual intrinsic complexity of these types of features and what's going on underneath.
So what you're saying, Nick, is that you write an immediate mode API over the top of Electron and just include Electron, and then you're done. That's the solution. That's how you write an
every
immediate mode.
frame you recompile the Electron app and relaunch it and redisplay a new one every time, because then you guarantee that it'll be correct, right?
But I must add that still you can have pretty decent text boxes, let's say that way, or minimal text editors in immediate mode. If you just cute some of the expectations, for example, to introduce some values.
Where do you draw the line?
Yeah, you draw the line.
Nice. So we're gonna do now the last question of the night, okay?
Oh.
What would you consider some hard things to do in UI outside of text? Like rounded, beveled corners or graphs? I was like already trying to provide an answer.
Well, actually, at the moment, I'm dealing with one thing that I don't know if it would be super difficult, but usually when you have to deal with Explorer trees, with like a list view with Explorer to explore a path with the directories and the files and everything. At the moment, I'm trying to implement one of those controls, and I think maybe I'm wrong, but I think it could be quite.
It's pretty tricky.
Quite tricky, yeah.
You mean like a nested, recursive kind of thing?
Yeah. Well, you got a path, and you have to create the tree for the path with the different directories and the files inside every directory, and show that information in a consistent way, and be able to select, maybe expand a directory or close a directory. Well,
yeah, and there's two versions of the hardness of that one, I think. One is if every row is the same height, and one where it can have widgets that are not the same height. And the reason is because of the culling. So like for the scene graph in Modeler, like Modeler supports hundreds of thousands of nodes inside the scene graph because you just grab stuff. But if you open the scene graph, we need to like not chug. And so you need to do that kind of ImGui style culling. But if you don't know how tall your elements are, good freaking luck culling. And so that's one place where, I mean, having knowledge about the elements is really important. And you effectively have to surface all that knowledge back up to the user because they have to do culling. Otherwise, your thing just hangs.
Yeah, it's funny. There's actually, that interface is built into the Clay itself. There's a...
I saw it.
You retained
right?
the power.
There's a debug view.
Yeah, in the debug view.
Arbitrary nesting.
Yeah.
Yeah. And it has expanding and collapsing of like the arbitrary levels of nesting and stuff. Surprisingly, no. When you have when like it essentially just uses because Clay has like a pseudo sort of global state of like the component that's currently open. So the container that's open. It means that you can create these things called like functional. They're referred to as functional components often, but it's literally just like a function that declares some UI. And then, so it's like you can open a container and then have a function that like will render the folder item or render the file item. And then you just call that repeatedly on the inside while you loop down through the things. I'm pretty sure it uses a stack, so it doesn't actually use recursion. It just pushes the children onto a stack and processes them in depth first order, basically. So it actually wasn't super duper hard to do.
But did you solve the culling somehow?
Well, they're all the same height.
Okay, so this is one of the like exposed assumptions, right? Because as soon as it's like you break that assumption, all hell breaks loose, right?
You know what the classic thing is? You're literally describing the difference between an array and a linked list. That's what it is.
It's deep.
It's like the things are all the same size. It's an array, so you can just use multiplication to figure out where the nth element is supposed to be. If they're different heights, it's technically a linked list because the height, the y position of a element depends on the height and y position of the previous element, right? And it just, that dependency chains all the way back to the very first element. So like, yeah, Yeah, that kind of stuff's so tricky. And again, it's one of those things where like people do it on the web and they're like, oh yeah, list of arbitrary stuff. Yeah. And then you take it to your game dev engine program and they're like, every list item must be the same size. Don't ask me why.
Yeah.
Okay. It has to be like that.
Yeah. Same size is the way to go. Definitely.
Well, you told me the crazy thing of like opacity, where because like in game dev, if you make something like 50% transparent, they're like, yeah, alpha 50%, and then you're like, that doesn't. When you have multiple containers on top, they kind of alpha blend out in a weird way. You're like, yeah, that's what alpha does. And in web, it's like, no, the container must render first, and then the whole thing alphas, and your game engine programs are just like,
yes, that's another this classic thing that we talked about. It's like something that web devs just really take for granted is the fact that you can take like a button or a modal, a pop-up or whatever. You take a pop-up that has text and images and other lines, other things nested inside it. And with a single line of CSS, you can adjust the transparency of the entire pop-up as if it was rendered as an image. Mm-hmm. Whereas from a game's perspective, of course, it's like, oh God, there's going to be, the text at opacity is going to blend into the background, which is then going to blend into the thing behind it. And like you end up with partial transparency happening. The colors end up all wrong and you can see half of things behind other things. Like, whereas on the web, as soon as you attach the opacity CSS attribute to a container, that container and the entire hierarchy underneath it get spat to a render texture first, and then that texture gets blended with opacity back on, composited onto the main thing.
So it's not like the browser's magically avoiding the problem. It's just letting you be like, oh, you changed one number in CSS. Yeah, we'll make a render target for you.
Yes, exactly. They just the action at a distance is just magical. You can do the most incredible things with just one line of CSS. Totally. Yeah.
So the question was rounded corners, or what was the other thing?
Rounded corners actually aren't super hard, surprisingly.
Yeah, rounded corners, you just round the corner. That's not too bad.
Sorry, that's the most game dev answer I've ever heard. It's like rendering 3D is easy. You just render the 3D, man. Like I don't see what the problem is.
Do the basics and like whatever.
For 2D rounded corners, you go to Inigo Quilez's website and you get the SDF for the rounded box and you slap that on, and then you put a little bit of feathering. And then you do that, and then if someone complains, you can like do more things. But like that's the easy. So it's just a box with a little bit of shader action happening. But the other one did seem. I remember. What was that?
Those graphs mentioned.
Graphs are So there's a reason like Omar's in the chat. There's a library that does ImGui plot, because it's like it's almost another rabbit hole, like graphs. Do they mean like I'm assuming they mean like plots of graphs rather than graphs of like, social media graphs. But like, you custom render stuff basically. So then like the way Clay works or ImGui, or I'm assuming probably Raylib similarly, is like you spit out a list of renderables and it's usually just boxes and texts. But you can create your own renderable types and just call it like my renderable, and you just give it an integer. And then you send that box along, and when the renderer gets it, it's like, oh, this is Anton's box. And then you just do your shader magic in there, and that's sort of how you do rendering. The state management problem shows up if you try to do transitions out. So if you have no transitions, it's brutally easy. You just send like some opaque user data, your renderer gets it. The UI doesn't even have to know about it. As soon as you have to do transitions out, the UI or somebody has to hold on to that data after it's disappeared, and then it becomes a thing. It's still doable. Like in the thing that I have at home, I have like a user data that gets copied over and it automatically carries user data. But if you want to use constructors and destructors, that's a separate question. Like you have to start doing inheritancy things where anyway, so it depends on how you want to solve it. But if you want to go straight C, you just put a user data pointer and you get it in the renderer, and then you can do a little bit of magic to hold that user data for a little longer after things disappear if you have to.
Yeah, I'd say this is very nuts and boltsy. Like if you've not implemented an immediate mode UI before, this probably won't resonate super strongly with you. But I'd say that like identifying elements from one frame to the next is a kind of open problem.
Sidestep that one. We sidestepped that one. That's the spiciest one.
Yeah. So essentially, the base case, right, is so okay. So the reason that we need to identify elements from one frame to the next in immediate mode UI is because there's naturally going to be some state that needs to carry over from one frame to the next. So, for example, if you want to have your clicks, your mouse interactions actually happen on the frame that they happen, you need some data about where the elements are. But how do you know where the elements are if you haven't laid them out yet? Right? So like if you need to use the click data as part of your layout, you need to know where the elements are, but you need to do the layout in order to get that. So generally we retain the bounding boxes of the elements as they were on the previous frame. And so as long as things aren't moving really quickly across the screen and like you're trying to, unless you have some insane UI where the box is bouncing like this and the user's trying to click on it like as it's bouncing really quickly. If you don't have something like that, it's really not noticeable that the bounding box for the UI element is one frame out. And so then you can get nice like on right inside the frame on the exact frame click handling. But the problem is, in order to be able to do that, you need some way to say, this element here that I'm declaring now for the first time in this immediate mode function, get me the bounding box of this element from the last frame. So there needs to be some way to know what that element was in the last frame and to find the bounding box that actually matches, right? So the classic way that you do it is you put an ID on everything. You put a stable hashed ID onto every UI element that you declare. And then from one frame to the next, the system now knows that, okay, check if this element's been clicked. I'll go and look up, I'll use the ID from the element that you've just declared. I'll go look up my structure that holds my bounding boxes from the last frame and I'll do the click against that bounding box. The problem is specifying unique string IDs for every element in a UI is quite cumbersome, and it actually becomes quite irritating to do at a very large scale. So like if you're doing like a big UI with thousands of elements, lots of components and stuff, it can get frustrating for people to have to think of a name for every single element. So there are a number of approaches to like, you can sort of derive an ID based on an element's position in its parent and, the
label,
path. Some
icon.
Yeah. Some people do stuff like the line of code, the line in a file, like the file name and the line in the file makes the hash and stuff. But the problem is in those cases, you're always going to have this issue where if from one frame to the next, you say flip the position of two elements in a list, there's no way for the UI system, which doesn't know about your data unless you provided an ID, there's no way for it to know that those elements have swapped position. So you'll get for one frame a bounding box that was for the other element if you flip them. So like on the frame that they flip, the bounding box will be incorrect if they don't have an ID, if this is with an auto-generated ID that's based on like their position. And it also means that like animations don't work because when you rearrange elements in a list, it can't tell that they've moved from one place to another. It just thinks that there are new elements in a different position kind of thing. So it's like an open problem that at least Anton and I don't think is really solvable. Like automatically generating IDs that know about these type of changes. Like
Modeler has auto IDs based on line and counter. So I went that approach, and that works well enough. Like it still doesn't work inside loops, but it's not the increment approach, right? It's sort of the line hash. Is that not Is there a hole in that approach?
A problem it's not, it's related, but it's not the same. But a problem I got with RayGui, I do not use IDs or anything for controls. Or I got no layout, so controls are placed as they are drawn, so they do not keep any kind of information. And a problem I found is that at some moments, some controls need to work in kind of an exclusive mode. For example, a slider, you start moving the slider and you go completely out of the slider rectangle, and you don't want the mouse to affect other controls while they still being able to move the slider. And the solution was kind of generating an ID that was the rectangle affected by the mouse. I kept that information and I enabled the exclusive mode until some action resets everything, and the rest of the controls are aware that they cannot be interactable while there is some exclusive mode control enabled. But it already needs to retain some information. It needs some global or some way to keep the state. Yeah.
Omar is mentioning in the chat that in Dear ImGui, semi-explicit ID stack is used to identify based on the labels. So you have like a path. You can access container, and everything.
The paths help a lot.
Yeah, so the only problem is that with the line numbers, is just that like if you're in a loop, you still have to require the user to say pass the loop index in.
There's no avoiding that. Yeah.
Or not even the loop index. You need to pass in like an ID that comes from one of the elements that you're looping over, because if you swap the order of two things and the total count stays the same, it's like we haven't figured out if there is actually a possible way to do it totally anonymous, like it just knows. If there's some way for the UI system to magically handle the ideas with no user intervention required at all, because it is a bit of a foot gun. Like at the moment, I've got this PR open for Clay where we're sort of debating whether we go with this, like the default macro expects you to always provide an ID, or whether the default macro always automatically generates one, and it's the fallback, it's the alternative API where you choose to provide one. It's like, do we make the default that we try and prompt people to always give one, and that's sort of annoying, or like those kind of choices really hard, and like it's an ergonomics problem.
It will be problems.
Well, I think
either way people will complain. It's the magic of open source, everyone.
Your API is really similar to modelers, Nick, and I think what we ended up doing is in the descriptor I have an ID for every element. And if that's set, then I use that. But if it's not set, I use the automatically generated one. So I just do both. I always automatically generate, and then I override with the user one, and then that seems to work. And then the auto one is based on file and counter, actually, not even line number.
Yeah, I won't get into it. There is a really irritating reason for why we can't do that.
Because you have a different macro something, or...
It's the fact that we have these magic functions that you can use as part of the element declaration. So when you declare an element, you can give it a background color, and then you can say if it's hovered, if the mouse is over the element, make the background color red, otherwise make it blue. Mm-hmm. But the problem is you're actually querying the state of the element before the configuration has happened, which is where the ID gets attached. So you actually need to know the ID before like I said, it's something that's hard to visualize, and it's like a specific edge case of our model, and I won't dig into it too much, but it's a huge pain, and I'll send you a rant about it later.
Send me a rant, because I think I might have just I in my home one you're also trying to provide like a nice API, but I think if you break it out into pieces and you say get the thing first and do no config and then do the config, but then it's like you're peeking behind the curtain in a way. So I think
it's also that C doesn't have optional args. And so you're limited to using macros if you want optionals and only in specific circumstances. So that also plays into it as well. Like our main macro needs variable args, so we can't really do a single optional and like it's just see stuff. See things, yeah.
Guys, I think that's it. I think we've got it. We've done it. Okay,
All issues solved.
Thank you so much. We figured it out, the UI programming. Now, for the round of shoutouts, okay? We had Nic Barker, author of Clay, who is now doing the course Joy of Programming. Why simple?
I think it was simple.
Joy of Programming.
Simple joy of programming, yes.
Yeah, you got it
Okay,
right.
simple Joy of Programming.
You got it right
On
the first time.
Patreon, look him up. Nic Barker. He has also amazing tutorials on YouTube. For example, on recursion. If you can't understand recursion, I would highly recommend to stick to Nic and replace your university teacher with Nic. Okay, at least for this one.
I produced probably the most deranged video about recursion in existence. I'm happy to accept that. I went way too far with it, but it will explain to you in detail how it works. So it starts easy though, and just gets builds on itself slowly.
We also had Ramon Santamaria, known as Ray, or Raylib, who made Raylib, and a lot of Ray tools, which you can check out. Some of them are paid, they're awesome, like Asset Packer. Some of them are free and open source. So if you're feeling lighthearted, I don't know if it's a good word, but if you would like to support open source and Raylib in particular, you can sponsor Raylib on GitHub. And GitHub is not, this is weird, this is not taking any cut. Actually, 100% of money you donate, sponsor through GitHub goes to the developer. So that's a good way.
Yeah.
For now.
To sponsor any project.
For now.
For now. So, did I miss anything, Ray?
No, at all. Thank you very much for the shout out. It's nice. Thank you.
Nice. And Anton, who is not having an open source library yet, okay, anywhere, who made awesome games, including Dreams and PS Move, it's a controller, PS VR, it's a VR, and now these debates wouldn't happen without Anton. Like, Anton messaged me at some point, like, let's do something. Let's do let's have people like talk about like technical stuff. And I was like, more than one person on podcast, it's not gonna happen. It's like, it's gonna happen. Like, let's do it. So we actually like this wouldn't happen without Anton. So Anton, thank you very much. It was an awesome idea.
You're welcome. I have some GitHub code that's just like snippets. I don't actually maintain the libraries like these two fine gentlemen. I just throw code that I can on GitHub and be like, hey, if you find it, it's useful. It's on there, man. Like, it's... Yeah.
What do you have?
Not accepting PRs.
Yeah, no, there's definitely no... There's not even commits. It's just like, first commit, job done. There's like I have like a random number generator that's cross shader and C compatible that does like good quality numeric random generation for like path tracers or just games. I also have a compiler for this esoteric language called Splat, which is a cellular automata programming language that has ASCII drawings. So it parses ASCII drawings and compiles them to GLSL compute shaders. So you can use that if you wish. You can program your own Splat and Ulam code. And then there's just like random code that I just throw on there.
Monsuma.
There's your math language as well.
Oh, yeah. I wrote a language just now for, like, it's not a real language, but it's a math calculator. So if you want to do, like, for quick calculations and things, I wrote, like, a little mathy language that does plotting. And then I have that AI project, that shall not be discussed. Otherwise, AI will blame things. But yeah, the calculator is kind of neat. I think people might like that.
Okay, there's a special question coming in directly from Omar to Anton. Anton, what do you know about bees?
Bees.
Is this
I have
is
some...
this like a... Is this like a inside information or what?
He's going to get it.
Please don't tell me these are all books about bees.
Bees.
What?
I have bee books. We should do a
Why?
bee podcast. There.
I wouldn't even come up with questions. Why? What's going on?
When
Why
we were
bees?
at Media Molecule, I guess it was back then, I wrote a beehive simulator. I don't think that's open source, but like there's a bee programming language that I wrote, which is like this language that sort of like lets you program insects and bees and do things like that. So it's kind of a cellular automata language of sorts. That's a visual programming language. But yeah, I still want to make a bee game, but like that seems even less commercial than anything else I have ideas about.
And that's saying something, right?
Yeah. CEO
Nice.
of Practical Ideas.
Fine gentlemen, thank you so much for joining me. Everybody in the audience, Omar, Taha, Nuno Afonso, who also tuned in. A lot of fine folk came and watched our discussion. Thank you so much for the attention. I will now put down all of the videos. They will not be accessible. It will be a couple of weeks when they will be finally edited, and then they will be available high quality on YouTube and everywhere else. Thank you so much. I will now turn off the stream. You please stay because Riverside will need to upload the stuff, so like we don't lose any of that. Thank you
Very
so
much.
much. And let's wave goodbye for everybody who stayed until the end. A lot of people actually did. But I think the issue is like with the animations with immediate mode, right? Like how do you handle, especially the stuff is like moving and needs to be deleted and stuff like that. You need to handle like tracking in a way, or maybe you don't need to.
So I think like Nick's hierarchy was good. So maybe we just do, if I remember it right, like obviously simple animations like bobbing up and down, sine wave, stuff that doesn't affect layout, like whatever, right? That's totally the renderer is the only thing. And I'm assuming you're assuming the same architecture as Nick and I, which is like the UI layout's kind of in the middle. Maybe it does input handling, maybe it doesn't. Mm-hmm. The user owns a bunch of state, including maybe the button styling, colors and whatever. And the user also owns the renderer. So that, it can pass an opaque, like, let's say brightness to the renderer, and the renderer like makes it might be even in the shade or whatever, right? So anything that doesn't affect the layout, no, it's like trivial, right? And then anything that only appears on that very first frame, well, the data naturally flows into the UI because it's like, you call do button and then you got the data. So at least for that one frame, you can imagine you've definitely got the data. Right. So the main question is like, what happens when it's trying to exit? Because there's this kind of thing of like, who owns the data? And
right.
Yeah.
So I think the way that I tend to implement this is that, and the reason why I don't think it's like, none of the calculus of the problems change between immediate mode and retained mode. And the reason I would say that is because the thing that allows you to have stable state and track animation state and so on inside of a retained mode API is that you have a stable handle to some underlying resource, which is the widget pointer, or if not a pointer, some kind of a handle or something like that. The only thing that actually changes when you move to an immediate mode API is the lifetime, the API, the lifetime of these. The usage code is no longer controlling the lifetime of one of these handles to a node. It's only controlling lifetimes of keys, which are plain old data that can be used to refer to the underlying resource. And so none of the things actually become any different. So in order to start doing things in an immediate mode API at all, like past some very bare minimum complexity, you have to start caching things. So if I say do button, that's got to be reflected somewhere in the cache. Like even to start doing things like click on release, for example. Like
exactly.
you press
I was
and then
going to
release.
bring that up.
Yeah, so that's like the very first thing where it's like, okay, you already need to start having some keying mechanism that allows you to take two do button calls across multiple frames and correlate them together with some kind of identity. The same mechanism can be used for because you're doing the caching. So I might need some help remembering the exact hierarchy, but like But let's just start with like the problem of like positions animated as determined by the auto layout engine. Mm-hmm. It's kind of the same problem. It's like the same node can have whatever state it happens to be drawing at, and then every time you run the auto layout pass, you calculate a new target position for wherever that position is supposed to be, and then you apply the animation step on every single node, every single frame. And so very, very trivially right away you get, okay, I've auto laid out this node to this position on this frame, on frame 0, and on frame 1 I've auto laid it out to a different position. And all I'm doing every single frame is drawing at some particular position, and then after doing the auto layout step, you apply an animation delta to whatever position you're actually rendering at. So that is like, and then similarly with like the death animation, there might be a better word for it, but death animation being like you have a panel, you close the panel. Yeah. The UI code which has been responsible for building that panel is no longer executing, but you already have done the whole cache. You've done You've done the cache of basically the way that I tend to write it is like I have the entire hierarchy still cached in memory. Yeah. Now you don't have to keep the entire hierarchy. It could be a command buffer, it could be lots of things, but it's some encoding of a hierarchy. Basically.
No, you want to keep the hierarchy almost certainly. Yeah.
Yeah. So at that point, it's like you just keep the hierarchy in the tree. You just don't recycle it. Yes. And then you could have some rules for like once this has stopped being built, and it's got the bit set that says do the fade out animation or whatever. Yeah. Then you just apply that.
So like for technical concreteness and interest, maybe if people end up watching it, the way Modeler works is we take all of the hierarchy. So as you do your add widget calls, I build up the tree, I have the tree, and then as you're going, I have the last frames tree, and I'm walking the last frames tree at the same time as I'm walking the new frames tree, and I'm doing an ID compare versus the last tree. And while everything is matching, it's actually like O of 1. You're just the base case is that it's exactly the same frame, so there's no real performance impact. If you have a mismatch, meaning like you added an ID that wasn't in the last tree, then you have to insert it into the new tree, and then you sort of diverge for a little bit, and the pointers kind of walk at different rates and stuff, and you have to be a little bit careful there. But then eventually either they reconverge, or you find that those elements from last frame weren't added by the end of the closure. And then you scan those elements and you say, okay, these old elements, I'm going to keep them around because maybe they're still animating out, but I've marked them sort of non-recurring. And so they sit around in the tree as sort of like these ghost nodes. Mm-hmm. So that diff is happening and that retention's happening. So I think we could assume that that's cool beans. And I think the ordering animation stuff, Nic might have to talk about, because I'm naively with your camp because I haven't done anything more sophisticated. I know he's been trying to do some more CSS-y things, so maybe it's particular to what he's trying to attempt. Maybe like in the way that one goes in front of the other, or some other state that's maybe a little bit subtle. I'm not really sure.
Yeah. So one key difference, I guess, is that I don't keep the. Basically, my data structure is simultaneously a tree and a hash table, so it's both. So the thing I actually build from scratch every frame are the tree links. I don't actually keep the tree. You would have to change this if you wanted to do. I don't happen to do death animations because I just haven't wanted them. But if you wanted them, you would do it the way I said. But what I tend to do is like every time you touch a unique ID every single frame, I zero out all of the tree links. So all the tree disappears basically immediately. Yeah. The thing that stays constant is like this node in the hash table, where it's like this is the constant state. So if you were to reorder nodes, nothing actually changes. The cache, both things are cached exactly the same way. They might show up in a different order of the per frame tree that's built, but that's actually not the important part for caching an animation. Like they'll just be animated to whatever position those unique IDs happen to be at. So it's sort of, it's not order dependent in that way.
But don't you? Well, okay, so maybe that's a hitch there, because first question is like, how are the IDs structured? Like, are they hierarchical IDs, or are they globally unique, sort of bunched together hashes like ImGui style or something?
I think so. I do use the ImGui
push hash, kind of like, or salt the hash with the hash with the prior or whatever.
Well, yeah, so I do that. And I took the trick of like, here's how you build simultaneously a display string, and you can add on extra hash details that aren't rendered. I took that thing, but the hierarchical hash. Actually, I covered this in my BSC talk too for a completely different problem, which is the watch window, like giant infinitely scrollable watch window problem, where you have to store sparse state and all this stuff. You have the exact same problem where you have this hierarchical key thing. Now, what you could do for that is like you could have a variable length key. It kind of sucks. An easy way to replace the variable length key is just to do a cumulative hash, where it's like, okay, you've got the hash of the top thing. In order to compute this hash, you seed the hash with your parent hash's value.
That's right. Yeah, like hash mixing. Yeah.
Yeah. So that in that sense, the keys are sort of hierarchical, but not in any way that could reconstruct the hierarchy. So the keys are globally unique. Well, not literally globally unique, but unique within the scope of the UI.
So if you happen to have two trees on two sides of your UI with the exact same paths, and one of them disappeared and the other one moved, you might have some strange, like if the names happen to be matched, you have an ID clash in two different places, you could get things like resorting in some somewhat strange ways.
So if you are wanting to control for that, with the way that I structure the API, you're not forced into the parent hashing at all. So you can choose a unique use, like a 64-bit value for any ID anywhere, and you could just use that as the key. Obviously, the convenient way to do it is compute it from a string, and then oftentimes to mix it with the parent hash. But if you do truly want, this is a key, and this could be completely in a different spot in the tree next frame, and I want to smoothly be able to transition between all these states, you just statically determine, without seeding any position in the tree hash, you just, here's the ID I want to use for this node, and if I use that in a completely different spot in the UI tree, which is pretty rare case, but it's if you were to do that, it's actually a rare case partly because the position in the call stack where you'd be building this is statically determined because it's statically compiled codes. But if you were to do that, just use this key somewhere completely different, then no problem. It's just the same node in the cache, and none of the positions in the tree are actually factored into the key at all. Off you go.
Okay. Wookash, did you want to interrupt before my...
because I messed up and it's actually live.
Awesome.
That was totally planned.
No, I wanted to click the record, but apparently it just it's
you just happened to click live.
So is it not recorded?
Just
then?
FYI.
It will be recorded, but it's just like additionally live.
Okay.
So
all right,
Ellie, come.
you want to show?
Okay, so I think the ordering one, I'm actually less qualified than Nick to speak on. So I think what you're describing is how the first one I wrote for Modeler works, where it kept a sort of hierarchical hash. And that part wasn't the problem. The problem is that I then attempted to use that hash to query data about nodes, and that was a disaster. And that's just not a good idea ever to do again. I exposed the IDs, and then I was like, oh, this will be cool for automation. Maybe you can press buttons. And it was I accidentally introduced the two states or state in two places problem, because now the IDs are how do you, and then anyway.
Right.
So that based in, DRMGui works the same way. The one I was more alluding to is that, okay, so when things die, I'm totally with you that you can silently keep the tree around. You can keep everything you know about around. And I totally also agree with you that the resource acquisition and release problem is a global problem. It has nothing to do with immediate mode or retain mode. I think it's more just immediate mode is so magical that people expect things to magically work. And this is one of those places where it doesn't magically work, because the nodes we can magically shimmy around behind your back. But if you give us an image, you bet we're going to call your renderer some 10 frames after you have stopped calling the execution code, and you better be ready, right? And so the question is more can we help you at all? And the answer is kind of well, no, not really, because in a retain mode API, I think people kind of naturally hit the problem, because there's maybe a callback for on enter, on leave. Oh, on leave, I'll free the image. That makes sense, even though that's probably a performance disaster, because now you're oops, I'm loading the image when I open the pop-up, and oops, I'm destroying it every time. Don't do that anyway. But then people are oh, I'll make a ref counted reference something, or maybe you do some kind of other hash something, and like,
yeah,
right? And so I think that's kind of where that rears its head, because in retain mode, I guess what I'm saying is the widgets are retained, and so you're dealing with the widget lifetime. So it's natural to tack on this lifetime of resources problem into it in a way. Whereas in immediate mode, we've taken away the burden of managing widget lifetime, which is the winning part. But then if there's resources, oops, like we haven't solved that in a way. So like in my own thing, I end up giving you a place to give a callback if you want to clean up that way, or if you're YOLOing and you're just going to statically allocate everything, sweet. Or if you're just manually going to know, like through some larger scope lifetime management, that look, this UI is running, things might be disappearing, but I'm going to keep my memory in the same arena that's active for this screen or whatever. So yeah, of course the renderer will have access to this memory. And then if the screen exits, I'm going to dump the whole arena, and then there's no problem, right? Like, so, but it doesn't free you from the lifetime of data, I guess, is sort of the insight there.
Right. I think so. I'm a little bit less qualified to talk about like shipping something as a library that other people call like if I don't ship my UI as a standalone library that people include into their projects, but I can talk about the way that I've solved this for the debugger at least, and the way I've solved it in other projects too, which is like I turn every single one of those lifetime management problems into an immediate mode problem. So it's like the texture handles should be immediate mode. That's the thing that makes this simple, is because and this, if I were to ship it as a library, my first thought would be, let me just take a key value, just like I do for the UI keys themselves, or the IDs for the nodes or whatever. Let me just do that for textures as well. And then the problem of like how to map a key, like since the renderer is user side, the problem of how to take a key, a unique U64-bit key or whatever, the way to take that and turn it into a texture handle or whatever that you use to actually specify to your renderer, that's your problem. Yeah. And the way that I like, that would be how I would structure it, and that is how that's how I structure it internally to the code base. The difference is when you're internal to a code base, you can just use the texture keying mechanisms or whatever that you control in your code base. So, but I would do it the same way in both cases, where it's like, my texture cache should work in the same way that my UI cache does, where it's like, I've got a key that I compute and I ask for the texture handle, and I can do that no matter how I compute the key. Unlike a handles-based system where it's like, I acquire a handle, I release a handle, that's all done in this management of the cache.
So that's the question, right? And so I'll press you slightly harder on that, is like, how do you know when to release the handle? Because like, that's kind of the core question. Obviously, like, for sure, pass handles, 100%. Obviously, you don't want to copy the resources. I also believe, obviously, the UI thing shouldn't own the resources. So God forbid you're like copying the whole thing in some God forbid thing. But like, who calls release and how do they know, right? Because in hand-rolled code, you can call release when you kill the widget internally, right? But if you're a library, you see what I mean?
So I never call release. I never call release from the UI building code. I think that's one key difference, is that like my UI code is all of the building code, like the thing that's building the widgets, it thinks of textures as immediate mode, like as immediate mode as the UI itself. So when it says I want a texture, it just says give me the texture for this, right? And it doesn't call release anywhere. The only person that's actually implementing the release is like if you imagine, let me rephrase the question back to you. Like when you've got this cache in your immediate mode UI system, where at some point you might want to recycle UI node storage. So somebody has stopped using a key for a particular widget, and you want to take that storage and reuse it, since like you haven't seen that key in at least a frame or 2 frames or however many frames you care to recycle for, or you care to wait before you recycle. Who does the freeing? In that case, who calls release node or who calls recycle node or whatever, puts it on a free list, whatever you want to do? Who does it? It's the implementation of the UI cache. It's the UI core layer, basically, which is saying like, oh, I haven't seen this key, and it's got an LRU linked list through the nodes or something, and then it's like, it goes through all the, it starts iterating from the least recently used to, forward, and then it says, well, this hasn't been used in this many frames, so I stick it on the free list. This hasn't been used in that many frames, so I stick it on the free list, and then it's like, it hits one that's new enough that it stops. And it's like, okay, I'm done recycling nodes, basically. You just have the same exact kind of system for texture caching as well, where you say, I am a cache that when asked, given a key. So this is in my terminology, I distinguish between key and handle. And I don't like to, like, how people call different things different words, so I don't mean to focus on the words so much, but this is how I distinguish in how I talk about it. A key is like a trivially computable plain old data value. And a handle would be something that you explicitly acquire and release from a system. So it's a handle's like an opaque handle where it's like acquire open this, close this, that kind
Handles
of thing.
might be garbage, keys can't be garbage is another kind of way of saying it, because garbage key is just it's a key.
Right. Yeah, you just like it. You computed this, you used it with the cache. You might get something, you might not, but the point is the key could be valid. Yeah. So I use texture keys, not texture handles. And so when you actually want to say like acquire or load from disk or something, nobody actually calls that except the implementation of the texture cache. You just, the usage code, like who's building the UI goes, okay, I'm going to draw an image. I need to find some way to get a key for this image. So it computes the key, and then it says draw a texture with this key. And then whenever you actually need a texture handle, like in the renderer or something, you say map this key to a texture handle. And that can include things like, okay, if it can't, let me take this piece of wood away from her. All right. Sorry, dog. She just had a dental surgery too, so I don't want her to be chewing wood. So you have a texture key, you map it to a texture handle, that relationship is completely managed in one spot, which is the cache.
Yes.
When you call release is a design decision of that cache. So you could say, for example, the same thing as the UI problem. You know, if this key hasn't been used in 1 frame or 2 frames or 10 seconds or however long, or maybe you only turn this on once you have to actually start reclaiming some storage because you want to save VRAM or something, you don't want to just leak these things forever, then it's like that is when you call release. And then so naturally, if someone stops using the key, you release the texture handle and you'll map it back in when they ask for the same key, but until they do that, you don't need to care. So that's who calls release. It's one other layer that's structured in a very similar way to the immediate mode UI layer, which recycles nodes in exactly the same way. Does that kind of make sense?
Yeah. So let me like repeat it back, and I'll maybe I can square what we're saying. Okay. So the way that the modeler system is written is I don't actually have a cache for the nodes. I just have like a previous and current buffer, and I just ping pong the buffers. So there's a tree, and there's some fixed number of nodes that you can have, which is generously set, and then you're just going to flip the buffer. So there's actually no recycling happening at all.
Okay.
But the reason that works conceptually is because we have enough memory in the system that's just free. You know, it's like a megabyte or something for like all the nodes you'd ever need.
Right.
But then one of the things we deal with in Modeler is like these giant voxel things. And so there might be an asset that's like, 40 gigabytes or something, or 30, large things, right? Things that you can imagine one may wish to release. And so like the canonical case, just to be concrete, is like someone brings up an asset browser and it's a UI related task and it's got a bunch of models in there, not even textures. And there's like tons and tons of vertex data getting like streamed in because you don't want to pre-stream it because you don't know what it's going to be. You open the panel and so things start popping in and then it pop. And then as it scrolls, something has to say, hey, this thing scrolled off because like I need some space to like put some more in. You don't actually have the memory to hold the entirety of things. So I think like things start changing a bit when you start to bump against the memory limits.
Oh my gosh.
Dog does not like memory limits.
Yep. All right. One sec. Yeah. Hey, come on.
Segfault dog. I segfaulted the dog.
Like it's almost midnight at my end. Like Nick is still in like with like a muted mic. We're like, okay, I wasn't supposed to like stream it. It's like then out the dog.
Yeah. So I think the punchline is, and I totally get where you're coming from now, is that you're basically saying, look, man, the management of how you deal with bumping against the memory is ultimately the cache's problem. And so if you have this scrolling list, that's just the problem of the the mesh manager, and the mesh manager should know that, hey, I haven't been rendered in 3 frames. I better eject this thing. So you basically just go all the way and you cache all the way, which I think is totally fair game. And so I think where we hit this problem is that programmers, on our team wanted to release things when things left, just sort of as a natural thought pattern. So when you're designing for that API, then you have to start doing these gymnastics of like, either I have to give you a callback of when I'm going to exit or blah, blah, blah. Now, it is still convenient sometimes if you want to manually just like dump a whole screen or something. But I think you're right that in the same way, immediate mode is beautiful because you don't have to do that. Forming everything as a caching problem is like sort of meta way of solving that issue better in general than even having to do that.
Yeah, for sure.
Exit cleanup kind of strategy.
Yeah, because I think basically I agree that people like programmers are used to the retain mode style of texture acquisition and releasing. Yeah, I don't think I think that's actually a bad pattern. I think the immediate mode one is actually the thing that is less bug prone, easier to write correctly. Because you said something where it's like, well, people want to write the release code, and I'm like, no, don't worry, you don't have to. You don't have to do any of it. It feels like garbage collection actually.
And I think that's I think you're right. It's like, because if you don't want to write the release code, the next question is like, well, who's gonna write the reference countdown code? It's like, no, there's no reference countdown code either, and it's like, but how do we get the memory back? And it's like, well, you get it when the cache tells you can have it. And so I guess the high level question is like, I can imagine scenarios where the latency of removing it as soon as it's gone is handy, because you're like, hey, I don't want to free it later. I know I'm done with it now, and I'd rather sort of do it now in the background and prepare for. So that's the only case where I can sort of sensibly make a performance vague optimization case of saying like, you know what, let's just give this back as soon as possible, because that's preferable, right? Because somebody in the background can churn and defrag if they need to.
Yeah, but it's hard, right? Because like even even when someone scrolls something out of view, that's not necessarily the right time to release it either, because they could just scroll back into view, and now it's like, okay, now I need to load it again. So this is all at this point, it's very heuristic. I think that a cache layer for like textures is in a much better position, or meshes for that matter, is in a much better position to solve this problem, because it can say things like, well, I have a lot of storage, I haven't used very much, and these days especially, like we have huge storage bandwidths or budgets is the word I was looking for. We have huge budgets for these things, so this is a very common case. But point is, it's like the cache can be in a situation where it's like, well, I haven't used very much, so I'll keep these around for much longer, and I'll only start really aggressively throwing these things away if I'm tight on storage. And so in the common case, or the very common case these days, where it's like you have a very low load of work, you're taking almost no VRAM, you're taking almost no CPU memory storage, CPU side memory storage. It's just like, you can mostly just cache things forever usually, and it's like fun.
And it naturally balloons to that size, and you don't have to worry about pre-allocation and all that stuff. So.
Right. And then if it ever became a problem where it's like, no, we need to start aggressively throwing these things away, that's just an adjustment to the caching layer. It's not really scary at all.
So in that heuristic world, you don't think there's any hints that the UI should give? I mean, it's just sort of a leading question. It sounds like no, but
I mean, I certainly haven't run into situations where it's true, because I do this, like, I don't have like assets like you do in a sense, but because in the debugger it's a very similar problem where it's like you've got a huge range of memory, you need to interpret it as like a texture or 3D mesh for that matter. Like, it's basically the same kind of asset streaming problem, just applied to debuggy state and at the limit files too. But it's and it's kind of like, I haven't ever really wanted any hinting, because the UI code, especially the code that's doing all these like visualizations and stuff like that, I want it to be very lax about this problem and just say like, look, just draw whatever you need to, and then the caches will sort this out. Now, you could imagine like, it's a very, you could imagine saying to a cache at some point, like, I'm going to stop using this for some number of frames, and I'm going to stop using this key for a while, but like, continue, like, you could set some parameters on how soon you want this thing to be evicted or something like that. You could start adding information as needed at the API site, You could also do preloading very trivially because it's just accessing the cache early, basically, for some keys. So you can start doing stuff like that. I've never really found the need to. So, but it's not out of the question. Like nothing about this solution to the problem actually disqualifies any of that. I just haven't found it to be useful in practice.
No, and I think you're right. And I think it kind of goes hand in hand with what we discussed, which is like you do immediate mode by default. And if you need to do something for performance, maybe you sort of funnel those things. But I think you're ultimately right because if something exits the UI, it also exits rendering, and so rendering will know, and you own the rendering, so you'll see it disappear from rendering.
Yeah.
For what it's worth, on the modeler, we give you the struct that you shove in as the image, and you define the struct, and so we mostly use a key. But then for the developers that want to use this UI that are more like OOP-oriented, they just replace that with like a manually or like an automatic smart pointer kind of thing that when it destructs, it sort of does its thing. And effectively, we just copy and compare these things. And it's like either you do C style and you do the L, or you cache in the back end, or you go OOP and now it's a magical thing. And we just make sure we call the destructors. So like you support both camps and both work. It's not a problem with the immediate mode approach. You can be an immediate or
I saw Wookash giving us the timeout.
Yeah,
signal.
I think we're good. We failed to fight. I agree.
Again, Ryan, you always promise blood. You always promise
want blood,
agreements,
and
and then it's like
didn't-
you come and it's like, oh, actually, like you can do this, and Andrew's like, oh, okay, actually, you can.
Well,
actually
my
do this.
consent-
Like, we just released the resource. It's like, oh, come on.
Well, the only thing I actually disagreed with earlier was Nick was talking about animations, and he was, and to be fair, it could be one of those things where it's like I would have worded it differently or something, but he was like, this is hard to do, and I was sitting there watching it. I'm like, no, like this is easier to do with immediate mode. That was my contention. So, but Nick's not here, so I can't talk with him about it. So you didn't get the
he's
blood that you
asleep.
wanted. I'm sorry.
He's asleep.
Sorry. Sorry.
All right, guys, thank you so much. We're really gonna stop streaming now, okay? There will be no surprise streams for the audience. Thank you so much for showing up for the surprise stream. Okay, we're gonna leave it in the episode to clarify the immediate mode releasing of the resource, when to do it, how to notify.
Sweet.
Just get good around it too. Not just in the UI.
Okay, like
Get good.
read blogs from Digital Grove.
Sure.
For some reason, I feel is the pronunciation of word grove sometimes groove? It's always grove.
Groove is like a it's like a music term. Like, oh,
thing.
getting in a groove. Like
You got two
It's
those.
two O's, versus one.
Oh, but there's groove. That's right. There's groove, which is like a groove in a piece of wood.
Is that one O?
That's with a U.
Guys, we really should read.
Good night.
It's a good night.
Right.
Like it's midnight.
All right.
Thank you. And shout out for
nice
dog.
talk though.
What's the dog's name?
Dog's name is Ellie.
Shout out to Ellie.
Ellie. Yes. I hope she's
Thank
doing
you.
okay. I let her inside, so. All right. All right, see you guys.
Good night.
Good
Yeah.
talk. See ya.